Good afternoon, everyone. My name is Bruce Hamilton, and I'm the chairman of the Defense Nuclear Facilities Safety Board. I will preside over today's hearing. I now call this hearing into order. I would like to introduce my colleagues on the board. To my right is Board Member Jesse Roberson. To my left, Board Member Joyce Connery. We three constitute the board. The board's acting general counsel, Ms. Casey Blaine, is seated to my far right. Several members of our staff closely involved with the oversight of the Department of Energy's defense nuclear facilities are also here. The purpose of this hearing is to understand DOE actions to strengthen the safety posture of solid waste operations and to gather information on safety controls to address the vulnerabilities associated with handling and processing solid nuclear waste at defense nuclear facilities. In the first session, we will hear testimony from Principal Deputy Assistant Secretary for the Office of Environmental Management, the Environmental Management Associate Principal Deputy Assistant Secretary for Field Operations, the EM Deputy Assistant Secretary for Safety, Security, and Quality Assurance, and the Principal Deputy Associate Administrator for Safety, Infrastructure, and Operations in the National Nuclear Security Administration. In addition, we will also hear from our technical director here at the board. Finally, Mr. Paul DeBar, the Undersecretary for Science, will provide us with a written statement for the hearing record following today's proceedings. The purpose of our first session is to discuss the DOE's actions to strengthen the safety posture of solid nuclear waste operations. Two recent events have highlighted the need for the department and the board to examine safety aspects of the storage and processing of solid nuclear wastes. They are the February 2014 radiological release event at the Waste Isolation Pilot Plant near Carlsbad, New Mexico, and the April 2018 overpressurization and subsequent radiological release from 4 drums at the Idaho National Laboratory near Idaho Falls, Idaho. These two events show that chemical reactions in the waste can lead to releases of radioactive material, both where the waste is generated and where it is disposed. Accordingly, today's discussion is going to focus on the hazards posed by undesired chemical reactions. For context, in both the WIP and Idaho events, the radiological consequences to human populations were inconsequential. The DOE investigation into the WIP event described intakes of radiological materials by personnel as low level with trace amounts of radiological contamination detected off-site. However, under other circumstances, exposures to personnel could have been more significant, and there are lessons that can be learned from these two events. Today we are discussing solid nuclear wastes, both those that are newly generated as part of the department's ongoing national security activities, as well as those that were generated in the past and are commonly referred to as legacy wastes. We will focus on solid transuranic wastes, those that contain greater than a statutorily defined concentration of certain radionuclides. However, some of the discussions will also be applicable to low-level waste. High-level waste and used fuel are outside the scope of today's hearing. Today's hearing was publicly announced on April 24th on the board's public website and subsequently noticed in the Federal Register on June 17th. In order to ensure accurate and timely information for the public, this hearing is being recorded through verbatim transcript, video recording, and live video streaming. The transcript, associated documents, public notice, and video recording will be available for viewing at our public website. The video recording will be available through our website for at least 60 days. Per the board's practice and as stated in the agenda, we will welcome comments from interested members of the public at approximately 3:30 this afternoon. A list of speakers who have contacted us is posted at the entrance to the room. We have generally listed the speakers in the order which they contacted us or if possible, when they wish to speak. Ms. Blaine will call the speakers in this order and ask that the speakers state their name and organization, if any, at the beginning of the presentations. There's also a table at the entrance to the room with a sign-up sheet for members of the public who wish to provide comment but who did not have the opportunity to notify us ahead of time. They will follow those who have already registered. We ask the speakers to limit their comments to 5 minutes in order to give everyone an opportunity to speak. Information should be limited to comments, technical information, or data concerning the subjects of this hearing. Board members may question anyone who provides comments to the extent deemed appropriate. The record of this hearing will remain open until July 20th, and until that date, members of the public, including those observing today's hearing live via video streaming, may submit written statements to the board to be included in the record. Contact information for submitting a statement is available on our website. We reserve the right to further reschedule and regulate the course of any hearing, to recess, reconvene, postpone, or adjourn this proceeding, and otherwise to exercise our authority under the Atomic Energy Act as amended. This concludes my opening remarks. I will now turn to my fellow board members for their opening remarks. Ms. Roberson.
I do not have an opening statement. Thank you, Mr. Chairman.
Ms. Connery.
Good afternoon. I'd like to start by thanking our witnesses from the Department of Energy for joining us today to discuss the safety management of waste storage and processing. I appreciate you taking the time from your busy schedules to talk to us about our concerns and to the public. To the public and anybody observing from Capitol Hill and the press, we do appreciate you taking interest in the safety of the complex and our work here at the board. And finally, I'd like to publicly acknowledge the work of our staff, our management staff, our legal staff, and our technical staff, who put in many hours of work in preparing for this hearing. As is known from public correspondence with the department, the board was troubled by the events that took place on April 11th, 2018 in Idaho with what we'll call an overpressurization event. 4 drums energetically ejected their lids and spewed radiological waste throughout a facility. Luckily, no one was in the facility at the time, sparing injury or worse. The fire department reacted, and while we aren't delving into those facts today, took some questionable actions. But again, were not harmed during the course of the event. Since the event, the contractor at Idaho has been diligently and appropriately decontaminating the facility, investigating the event, and has even resumed waste processing of the material that was co-located with the drums that erupted. The department declined a federal investigation and opted for the contractor to conduct its own investigation. Root causes of the event were examined, and a hypothesis was laid out by the contractor as to the cause of the event. The event itself was not incredible, yet it was also not predicted, analyzed, or controlled for. In February 2014, a drum within the waste isolation pilot program also erupted and ejected material and contaminated the single waste facility in the complex that is certified to permanently dispose of transuranic waste, closing that facility for nearly 3 years and costing hundreds of millions of dollars. There is waste throughout the DOE complex, some of it newly generated, some of it dating back to before I was born. Some of that waste is well characterized, predictable, and safely stored. Other of that waste is being dug up because it was improperly disposed of, is not well characterized, and will need to be treated and or repackaged before it reaches final disposition, whether that be at WIPP or someplace else. Following the WIPP accident, there was a federal investigation. Lessons learned were promulgated and corrective actions taken. The whole complex was alerted to the event, and presumably precautions were taken to avoid a repeat event based on the information that was gleaned from that accident. So this leads us to some very logical questions. And these are the questions we'd like to explore during this hearing. What was not done post-WIPP that could have predicted, prevented, or mitigated the events at Idaho, if anything? Why was it determined that a federal investigation was needed at WIPP but not at Idaho? In May of this year, over a year after the Idaho event, DOE's Environmental Management Office issued a safety alert to garner information from across the environmental management site. This is what we call an extent of condition, to determine how sites assess and control risks from radioactive drums with uncertain or unknown waste streams in their documented safety analysis. While this safety alert is consistent with the information that we, the board, requested from the department, why didn't the department initiate this request for information itself in a more timely manner? The safety alert only pertained to environmental management sites. Why wasn't the department corporate operational experience program used in order to assess the risks across the whole enterprise? Are there other drums subject to chemical reaction events, either through postulated mechanisms of the Idaho event or through some other confluence of circumstances? Are there other drums stored at waste generator sites that could undergo a chemical reaction with similar effects? And if so, are those drums in a safe storage configuration? Are they safe during processing? Are there sufficient controls to prevent, detect, or mitigate future accidents? Is the department consistent in applying its standards across the complex to ensure that the workers and public are safe? And lastly, the standard itself, 5506, which the department has been talking about updating since 2015, is that sufficient to protect the sites that are processing and storing waste? It's important that the department maintain consistency of approach, be predictive in its analysis of hazards versus reactive to the last challenge it faced, and be transparent about the areas in which improvements can be made. I'm hoping that we can have a good dialogue through this hearing to get a better understanding of how the department sees these events, and perhaps even ask questions that you will find useful as you develop your path forward on revising your standard, communicating your expectations for implementation, and engage in your mandatory regulatory and oversight role. I would note that this hearing, we had some timing difficulties, and I want to apologize to folks in Idaho. I realize that there's a concurrent meeting of the Idaho Cleanup Project Citizens Advisory Board, and they've expressed concern about the timing of the hearing. So I apologize that we could not have done it at a more convenient time for them, but we look forward to any interaction that they'd like to have with the board. That concludes my opening remarks.
Thank you, Board Member Connery. At this time, I'd like to introduce the panel itself. Todd Schrader is the Principal Deputy Assistant Secretary in the Office of Environmental Management. Jeffrey Griffin is the Associate Principal Deputy Assistant Secretary for Field Operations in the Office of Environmental Management. Chung is the Deputy Assistant Secretary for Safety, Security, and Quality Assurance in the Office of Environmental Management. And Mr. Ted Wyka is the Principal Deputy Associate Administrator for Safety, Infrastructure, and Operations for the National Nuclear Security Administration. So welcome, all four of you. Thank you for being here today. Also on the panel is our Technical Director, Mr. Christopher Rossetti, and we are pleased to have all of you here today. I'm going to start the series of questions with Mr. Rossetti, our Technical Director. Mr. Rossetti, we understand that both the February 2014 radiological release at WIP and the April 2018 overpressurization and subsequent radiological release at Idaho National Lab involved chemical reactions in solid waste. Would you briefly describe the significance of those events for us?
Yes, sir. I would like to enter Exhibit 1 into the record. Exhibit 1 shows photographs following the 2014 WIP event and the 2018 Idaho event. Both events involve the rupture of waste drums and the release of radiological material from those ruptured drums. The picture on the left shows the ruptured drum at WIP. The pictures on the right show 2 of the 4 drums that ruptured at Idaho's Accelerated Retrieval Project. Exhibit 1 shows that the contents of the drums at WIP and Idaho are spread around the areas surrounding the drums. In addition, the lids from the Idaho drums have been ejected. Both events had an impact on the department's cleanup mission. Although the actual radiological consequences to the people were limited in both events, this is only because of when the drums ruptured. Given other circumstances, exposures to personnel could have been more significant, and there are lessons that can be learned from these 2 events to help prevent future occurrences. For example, the WIP event occurred when normal work was not being performed due to the February 5, 2014 Salt Hall truck fire. In addition, the Idaho event occurred at night when no workers were present. If workers had been present during either of these release events, there would have been more potential for worker exposures. In short, no one experienced significant exposures as a result of either the WIP or the Idaho drum ruptures, but both events have affected the department's cleanup mission.
Am I correct that that photograph on the left, what looks like a big layer of detritus is not from the container? What is that I'm looking at there?
Yes, sir. This is one I will have to clarify through the record, but my recollection at WIP is that they place a large bag over the configuration of the drums and waste boxes stored at WIP. The drums are stored in like a 6x6 or a 6x3 array, so there's about 6 drums, and this bag fits on top of those 6 drums. And I forget what the contents of that bag is.
Okay. I just wanted to make sure that nobody thought that material was what was ejected from the drum.
Right, not all of that material.
Not all
and
of that,
the picture on the left is from the drum. It's from the bag that's used on top of the drums throughout the mine to, I believe, potentially suppress fires. But I will clarify that for the record.
Okay, we can clarify that later. Would you describe the solid waste that we're discussing today, please?
Yes, sir. Both the WIP and Idaho drum ruptures involved solid nuclear wastes. So these wastes exist in a wide variety of forms. They include sludges, surplus uranium and plutonium, and other contaminated materials, such as contaminated wipes, rags, filters, soils, or equipment. Some of the department sites store legacy waste that were generated decades ago. Other sites continue to generate these same sort of waste materials as part of their ongoing missions. Both types of sites are commonly referred to as generator sites. Some of the solid nuclear wastes will be categorized as transuranic or true waste. Other solid nuclear waste will be designated as low-level waste. The plan is for generator sites to ultimately ship their true wastes to WIP for permanent disposal in the geological repository. I would like to enter Exhibit 2 into the record. Exhibit 2 provides an overview of the scale of the department's solid waste mission. The first slide of Exhibit 2 describes the progress Idaho has made shipping waste to WIP, processing waste, and certifying waste for WIP. It also shows the amount of waste remaining to be exhumed and processed. Of the legacy true waste and low-level waste, about 86% has already been shipped to disposal sites such as WIP. About 11% needs further processing or analysis before it can be certified for shipment. To help visualize some of these numbers, the 9,700 cubic meters of waste, which are the 2 center rows combined, currently above ground at Idaho is equivalent to about 40,000 mostly 55-gallon drums. The second slide of Exhibit 2 shows the amount of current and future true waste at other DOE sites. While the department is making progress, the solid waste mission will continue for years.
Thank you, Mr. Rossetti. Ms. Roberson.
Mr. Chairman,
Yes,
I'm sorry. We would like to make some opening remarks, if that's possible, before we enter the question.
You know, it is, and I think I may have skipped over that. Let me see. Do we have that in here?
No.
No. Is there any objection? Okay, go ahead and make your opening remarks. I didn't believe, the information we got was that you didn't have any, but since you do, go ahead.
Okay, thank you very much. So, good afternoon. I'm Jeff Griffin, Associate Principal Deputy Assistant Secretary for Field Operations in the Office of Environmental Management. And on behalf of the Department of Energy, I welcome, and we all welcome, the opportunity to provide opening remarks today, for this session at today's public hearing on safety management of waste storage and processing in the Defense Nuclear Facilities Complex. I want to thank the Board for the opportunity for open and transparent discussions, recognizing the topics we'll be discussing today are of mutual importance to DOE, the DNFSB, and our stakeholders. I would like to introduce the others, and this will be for both panels, starting with Mr. Todd Schrader. And although while he was recently appointed Principal Deputy Assistant Secretary for Environmental Management, today he will be representing his former position as manager of the Carlsbad Field Office, which is responsible for the National Transuranic Waste Program. Also participating in the panel are Mr. Jack Zimmerman, Deputy Manager for the Idaho Cleanup Project, Mr. Dave Chung, Deputy Assistant Secretary for Safety, Security, and Quality Assurance, and Mr. Ted Wyka, Principal Deputy Associate Administrator for Safety, Infrastructure, and Operations for the National Nuclear Security Administration. We look forward to a constructive dialogue with the board that can provide a clear understanding of the actions and intent of the Department of Energy as they relate to waste storage and processing throughout the DOE enterprise. The safety of our workers, the public, and environment is always our top priority. We recognize the work we do is hazardous, and the implementation of the proper controls is critical to the safe operations and adequate protection of public health and safety. A common theme for today's discussions is the potential for chemical reactions in some of our waste. We are specifically discussing the event last year at the Idaho Accelerated Retrieval Project, or ARP, and the 2014 event that led to a release at the Waste Isolation Pilot Plant, or WIP. We fully understand the root cause of both the WIP and ARP issues. In the event leading to the 2014 release at the WIP, the reactive nature of the waste was directly due to the use of incorrect materials in the processing of the well-known waste stream. The root cause corrective actions for the WIP event are designed to prevent a similar adverse effect on WIP, and from that standpoint have been highly effective. The more recent ARP event is different in that it involved legacy waste that was processed without detailed knowledge of its contents. In fact, in this case, the waste was undergoing visual examination in an effort to aid in the characterization of the waste as one of the first steps leading to eventual certification for transport to WIP. The waste in question processed at ARP had not yet been shown to meet the WIP Waste Acceptance Criteria, or WIP-WAC. It was far from being certified for shipment and could not have been accepted by WIP without significant additional characterization and review. While lessons learned from the WIP event are informing waste processing and packaging at the generator sites, the processes and controls developed to protect WIP did not apply directly to the activities or issues involved in the ARP event. The ARP event serves as a significant opportunity to apply lessons learned, particularly when dealing with legacy waste and/or waste with uncertain characteristics. To that end, the Department values the sharing of lessons learned that will significantly minimize the risk of recurrence and maximize worker protection, not only at WIP, but at other generator sites across the enterprise. Following the completion of the extensive root cause analysis of the ARP event, a safety alert was generated and issued under my signature to all the EM waste processing sites. It is important to note that we included all waste processors, not just true waste processors. The safety alert provides lessons learned to processing sites and requires responses to headquarters on actions taken and potential inventories of legacy waste to be processed. The safety alert also considers potential deflagration hazards associated with the storage of processed waste, which was not the case at the DOE Idaho ARP 5 event, which was drum overpressurization. It is important to reiterate that the event at ARP did not involve a deflagration, but rather an energetic pressurization that overwhelmed each installed vent. This safety alert was also informationally provided to other DOE program offices to alert them to the event. And as a follow-up, EM is working closely with the Associate Undersecretary for Environment, Health, Safety, and Security to issue a formal operating experience report, or OE, incorporating the objectives of the safety alert to all DOE program offices that process waste. That OE is currently in the concurrence process for issue. With respect to oversight, DOE maintains full control of its true waste program and the safety basis infrastructure that governs it. We also rely, where necessary, on independent experts such as the national labs to support our efforts. The implementation of the WIP-WAC has been successful in preventing unacceptable waste forms from being sent to WIP. For processing of waste at local sites, the needs are often specific to the waste form, and the required experts are engaged to ensure appropriate control sets. The lessons learned from the ARP event will be incorporated into our future operations. I would also like to address the Board's previously documented concerns with DOE Standard 5506-2007, preparation of safety basis documents for transuranic waste facilities. We did make significant changes to the hazards analysis at WIP because of the 2014 incident. The hazards analysis was modified, and Chapter 18 was added to the WIP Documented Safety Analysis, or DSA, with the realization that accidents resulting from chemical incompatibility could exist at WIP as a result of activities undertaken at a generator site. Increased emphasis was placed on assurance that the WIP-WAC was met prior to receipt of waste at WIP for the protection of public health and safety. Elements of this increased emphasis include enhanced chemical compatibility evaluations, added emphasis on the basis of knowledge background of legacy waste, and enhanced reviews and oversight of the certification of waste prior to shipment to WIP. It is fair to say that these activities were not intended to protect waste generator sites for waste yet to be certified for shipment to WIP, where it protects such waste handling and processing activities at the generator sites are appropriate evaluation of activities, an appropriate hazards evaluation, and establishment of controls to protect those activities. DOE Standard 5506 is directed at analysis of postulated accidents from an appropriately thorough hazard assessment. DOE is currently in the process of revising Standard 5506 to incorporate lessons learned and feedback from the board and the rest of the DOE complex. In conclusion, the board provides valuable insight and advice that the department both appreciates and takes into consideration. Our work is critical to lowering the environmental risk posed by the legacy of the Cold War. This requires us to take on hazardous waste streams and legacy waste streams that unavoidably lack complete information and documentation. Especially for such waste with uncertain or unknown components, the potential for adverse chemical reactions cannot be eliminated with 100% confidence. There is no zero risk. We must recognize that there is risk in doing nothing. Our expectation is that this potential is minimized greatly by establishing rigorous and appropriate control sets to protect the workers, public, and environment. Thank you again for inviting us here today.
Thank you, Mr. Griffin, and that's a lot there. I think we may replow some of that as we go through our questions, so keep that statement handy. You may want to refer to it a little bit more, and if you're you may also want to go back and look at the reaction that I got from the chairman of the House Armed Services Committee, Strategic Forces Committee, when I said that there is no such thing as zero risk. It wasn't a good day. Okay, Ms. Roberson, please.
Thank you, Mr. Chairman, and good morning, and thank you to each of you, and thank you, Mr. Griffin. Actually, you started to answer a question. My first question is actually to you, and I would say to you, the board fully understands that there is no such thing as zero risk. What we're focused on is that there's credible awareness of those knowns and risk as action is taken, and that there is a careful approach, just like that EM applies to how it approaches D&D. So with that said, I mean, we're going to talk a lot about safety, but I want to offer you the opportunity, since you didn't do it in your opening statement, to characterize, as we have noted, some of the considerable accomplishments EM has made in its solid waste management program.
Sure. I'd be happy to do so. So I think Mr. Rossetti, pretty well described the progress that's been made in many areas. If I go back to 2014 and look at the accomplishments, that was obviously a very impactful event. And I think, and I'm sure we will discuss this more through today's session, but I think there was a tremendous number of lessons learned and a tremendous impact across the entire program in terms of, and I listed some in my opening remarks, but we obviously have great improvements in the in processes for certifying the waste for WIP. We've made structural program changes in terms of how we provide interface between headquarters and the sites, as well as between the Carlsbad Field Office, the National True Program, and the generator sites. The result has been over 500 shipments since we reopened at WIP. We've even averaged in the month of May 10 a week. So we've really dramatically increased. And this is from multiple sites, not just Idaho. Of course, Idaho does tend to dominate when we have new sites ready to come online. So I think we've taken those lessons to heart. We've made, it's been, as I think the chairman's opening statement made comments about the recent years, but in just a couple of years, we've made a tremendous progress in getting things back on the road. This is a critical program for the nation, right? I mean, this waste cannot be left untended. We have to deal with it, and we are very serious about taking it very seriously, our responsibility to deal with it appropriately.
Thank you. So, actually, my next question is to tag on as the manager, kind of responsible for overseeing in the EM world, the generator sites. What are the things that you're concerned about in this particular mission area as the mission is executed? You talked in your opening statement about sometimes not knowing what's in the waste. We understand that. In some cases, I mean, we're looking at specific activities at specific sites. In some cases, the site's dealing with waste above ground still has waste below ground. In some cases, you may generate kind of unique waste as a result of treating other waste. What are the things that are on EM's leadership team's screen as it relates to this mission?
Yes, thank you. My concerns, our focus as a EM leadership team in that area are to make sure that each site has to deal with their own particular set of issues. Idaho with the buried waste, and in some other cases it's more newly generated waste, legacy waste with different histories. It's important that we help those sites have all the resources they need to deal with their waste, to understand, to have the knowledge, the background, the information that's necessary to assess what needs to be done, what characterization is needed, what treatment may be needed. And we try very hard to help support those sites on their individual situations like that. So that's why we have the National True Program to help cut across the entire complex and deal with the individual challenges at each site in order to help create this flow of waste that goes to WIP and meets the requirements at WIP.
Yeah, I assume that applies even like at some sites. It only becomes true once it's characterized. So I assume that applies even before something is deemed true waste. Is that right?
So, yeah, it's true of. Sorry, it applies to almost anything we deal with, right? I mean, you have to deal with what you have to recognize where you have knowledge, what you don't understand, and then you have to use information you have available, the expertise that we have in the complex that we have through the national labs that we have across headquarters and across the sites, and to understand what you have, whether we're talking about true waste or something else entirely. So, yes.
Thank you.
Thank you, Ms. Roberson. Board Member Connery?
So I appreciate your opening comments, and we're trying to get some information out so the public has context. So I'm going to ask Mr. Rossetti, in the interest of time, to provide a brief overview of the department's processes for managing safety during waste storage and processing.
The individual facilities at generator sites and WIP each have their own safety bases. The safety basis is the tool that the department uses to systematically identify hazards related to a facility, estimate the consequences of potential accidents, and identify controls to prevent or mitigate the consequences to protect the public. The department's contractors typically use DOE Standard 5506-2007, preparation of safety basis documents for transuranic waste facilities, to help determine which accident scenarios to analyze and how to analyze them. For events with potentially higher consequences, the department implements controls that are more reliable. These are called safety controls. Different facilities may identify different control strategies based on their own analyses and circumstances. The objectives of today's hearing focus on postulated accidents that may be initiated by undesired chemical reactions that occur in the waste. Session 2 of today's hearing should cover specific controls for these scenarios.
So Mr. Griffin described for us the fact that each site have unique needs that the headquarters helps support, but as Chris just noted, and it was noted in both my opening and Mr. Griffin's opening, there is kind of an overarching standard, 5506, that kind of guides this. Since 2015, the department has been in the process of revising the standard And in early 2018, the board transmitted Tech Report 43 noting the deficiencies in the standard. And as you noted, you're undergoing review, and I was thrilled to hear that last week, coincidentally, there was a workshop to discuss some of these issues to maybe move this forward a little bit faster than it's been going. So my question is to Mr. Chung, can you just describe the status and schedule for updating Standard 5506 and the plan for incorporating lessons learned from both WIP and Idaho?
Sure, thank you. Before I answer that question, since I was the lead for the original effort that published 5506 standard 12 years ago, roughly, I feel as the former technical lead for that standard that standard has provided its intended purpose and objectives in terms of standardizing the way we would analyze the hazards that are typically associated with true waste operations, which includes both processing, treatment, as well as storage, in the context that it makes sense for providing those control set, which goes beyond just the safety-related controls, that would provide reasonable assurance for adequate protection for both public as well as workers. That went through a great deal of consensus building, including the board at the time. As I recall, that standard was supported by the board as well as the rest of the department. The other thing I'd like to mention is that 5506 standard does not stand alone as the set of controls or programs that provides adequate protection. 5506 is a supplemental guidance to one of the safe harbors that are called out for in the section subpart B of the 830, 10 CFR 830. The other thing that's important to all of us, I believe, is that we have many relevant safety management programs, things like radiation protection programs, hazardous material protection program, industrial hygiene program, maintenance, conduct of operations, QA. So there's all sorts of relevant programmatic elements that provide another strong basis for a safe operation. So I'd like to point out that while 5506 standard provides important role in terms of providing upper tier set of controls from a nuclear safety standpoint, we do have a suite of directives and resulting controls that we apply during our day-to-day operations. Not so unique to a waste processing operation, but throughout our nuclear operations in the complex. With respect to your pointed question in terms of status of the standard 5506, one of the reasons that we have waited until very recently to resume that effort is twofold. One, we wanted to make sure that we have a thorough understanding of the ARP5 event in terms of the technical root causes, in terms of any other management or other types of root causes or causal factors that may have contributed to that event. It took a while for our contractor folks and their corporate folks to be able to develop very defensive root cause analysis and associated corrective action. So that was finalized back in February of this year. The other thing that we were waiting for was some of the results that we were getting from the Sandia fire-related test results, as well as any additional test needs that we may want to pursue. So we felt that this is the right time to resume in terms of having the right type of people. I think we assembled a pretty good group of experts last week to basically resume that effort, and my direction to them was to let's go through the entire 200 plus pages of the standard very carefully. Let's look at all of the feedback and comments that we have received from the complex, from our federal colleagues as well as from the contractors, plus the issues and concerns that were raised in the Defense Board's Tech Report 43. So we believe we have a pretty thorough understanding of the overall needs going into this resumed effort to revise the standard. And as of this morning, we have issued a project justification statement to our corporate ES&H, which means that there's a 15-day review process for that justification for revising that standard. And then we already have received some preliminary feedback from places like Hanford in terms of their overall consolidated comments on the standard. So our plan is to go through what was laid out in the justification statement for revising the standard. And roughly, we think that by next year, this time, that we would have that hopefully published. So if you back off in terms of drafting the revision to the standard in various sections, we're probably talking about 6 to 8 months from now to have a final draft, and then that will allow adequate time for what is known as a RABCOM process for complex-wide review and approval.
Thanks, I appreciate that. Just a quick technical question. So the project justification document that was issued this morning, which we haven't seen yet, does that supersede the one that you put forward in 2015? Because it was already a justification.
It supersedes and supplements
Okay.
that
Okay.
document with some a little more detailed information that captures what we know today versus what we had known in 2015.
Okay, I appreciate that. That's we look forward to seeing that, and I also appreciate the description of the fact that 5506 is nested into a number of other standards and directives. Obviously, we follow those very closely, but I wish we had time to talk about revisions to 830, but we'll save that for another conversation. But I'd like to turn, since we've been talking about Tech Report 43, to Mr. Rossetti to just describe the staff's assessment of the standard based on some of the information that we provided in Tech 43.
As I said in my other testimony, the department's contractors typically use DOE Standard 5506-2007 to guide the development of safety bases for facilities that process and store true waste, in addition to the other department standards and safe harbors. In 2018, the board issued Technical Report 43, Deficiencies in DOE Standard 5506-2007, Preparation of Safety Basis Documents for Transuranic or True Waste Facilities. This technical report provided the board staff's assessment of weaknesses in the standard known in 2018. I would like to enter Exhibit 3 into the record. Exhibit 3 quotes one of the deficiencies discussed in the technical report. The 2014 WIP event highlighted the fact that undesired chemical reactions can lead to releases of radiological material. While Standard 5506 recognizes this fact, the standard provides relatively little guidance on how to analyze and how to control such hazards. To the extent the standard does have guidance on chemical reaction hazards, the board staff is concerned that the standard underestimates the potential consequences of such events. After the WIP event, the department determined that the amount of radioactive material released was significantly greater than currently considered by DOE Standard 5506. This is important for the entire complex because the amount of radioactive material estimated to be released during potential accidents is used to identify safety controls to prevent or mitigate such accidents. The board staff has performed a cursory review of the safety bases for true waste facilities and found that several facilities have not incorporated updated release parameters for an energetic chemical reaction into their safety analyses. Including this information in the safety bases could drive the department and those specific facilities to identify additional safety controls that could help prevent or mitigate an energetic release event. Since the board issued the technical report, the April 2018 Idaho event occurred, which the board staff believes provides additional information related to release parameters. As with the WIP event, the board staff believes this information should be incorporated into Standard 5506 in the facility safety bases.
Thank you, Board Member Connery. Ms. Roberson.
Thank you, Mr. Chairman. So we're talking about 5506, and I wanted to say my question is actually, I have several questions for you, Mr. Chung, but I appreciate your comment, and as Ms. Connery said, we spend a lot of our time evaluating the execution of the safety management programs, as do you and your staff. And we know the execution isn't always consistent and predictable across the sites and across the programs, which is the reason why it's so important to take a step like EM did in issuing the safety alert. And so I want to enter that safety alert on the record of the hearing as Exhibit 13, and a copy of it is on the resource table in the back, and it's also on our website. And I want to ask you, Mr. Chung, to summarize the environmental management safety alert.
Thank you. I'm just going to summarize what we have communicated in that written safety alert that Jeff mentioned. Not only that we have considered the two main causes that were identified by the contractor-led investigation, as well as their corrective action, we also looked at the 8 contributing causes, which include some aspects of safety culture, things like how to manage changes, how to detect and also act properly when you see potential change in conditions of the waste. So it was just more than dealing with a pure technical aspect. So, and we've actually had some discussions with the field, those that have generated waste and still are, to look for their immediate input in terms of their reaction to what they have read or heard. So, which culminated in the issuance of the safety alert. So, the safety alert applies to all of the site waste generating activities, waste previously generated on site and now stored or being repackaged, retrieval and repackaging of legacy waste retrieved from other sites as well. If you look at the safety alert, we require certain actions, then we also have some recommended actions. Let me just give you an example of required actions. So it is required for each site to complete a site-specific extended condition review for radioactivity and mixed waste drums in storage that have not been certified. And there are 7 criteria or questions that they must encompass in terms of performing their site-wide or site-specific extended condition review. Identification of flammable gas, testing protocols and frequency of testing. Identify the circumstance in which flammable gas testing is not performed and the rationale for this approach. Identify the number of waste drums containing flammable or near flammable gas concentrations and the controls in place to mitigate the hazard. Identifying the inventory of waste drums that contain or could contain metal carbides, including waste streams yet to be discovered or recovered or excavated. Identifying the inventory of waste drums which with uncertain process documentation to determine pyrophoric and flammable gas generating potential. Describe the processes in place for monitoring and managing these uncertainties in waste management activities. And also we asked them again to evaluate any waste condition of concern that are identified in accordance with DOE Standard 5506, including all of the lessons that were either already applied or should be applied from the WIP event as well. Chris mentioned about the importance of predominantly the release fraction that resulted from more energetic chemical event at WIP, which was applied not only to the WIP facility but also for the remediated nitrate salt, the resumption operation at Los Alamos. And there was, I believe, operating experience report that was issued back in 2015 to highlight that concern to the complex. And those 2 sites were the sites that responded in terms of the need to apply the higher release fraction, which will obviously give us a higher consequence estimate. So the site-specific extended condition reviews would be collected and compiled We asked the sites to submit their input by end of September, and then we will put together a small but very strong team at headquarters, which may include some other outside experts, to look at all of the site-specific extended condition reviews to come up with a complex-wide extended condition review and lessons learned. That is the plan for addressing the required action. There are also quite a few recommended actions, which include some of the non-technical aspect, like, let me just point out a couple of things. Thank you, Jeff. Promote continuous improvement in site safety culture, where workers can express an inquisitive attitude toward challenging assumptions regardless of potential impact to cost and schedule. Similar aspect of this was already identified by the Idaho floor contractor as part of their causal factors or contributing causes. So we think that that is an important factor into dealing with the uncertainties. Recognizing that no matter how good your hazard identification or hazard analysis or accident analysis are, you're going to have that element of uncertainties. And we believe that it's very important to have not only well-trained and qualified operators, but we have to continue to provide a positive safety culture so that they are able to pause or ask right questions in terms of managing that changes that I mentioned earlier.
Okay,
So,
thank you.
in a nutshell, that's what the safety alert contains.
Thank you so much. One short question, you didn't require this, but you didn't preclude it either. If in doing that data gathering and analysis, is there an intent that the site make changes, for instance, to its facility safety basis if it identifies information? But you didn't require it, but that is your intent?
Yes.
Okay.
You know, just if I may add, we do have a pretty good engagement in terms of what's going on in the field. Many of our headquarters staff are deeply engaged in either supporting or providing oversight / insight in terms of development or changes to the safety-based documents, in terms of revising fire hazard analysis, which is also a very important element of developing adequate safety basis, which should be provided to the hazard analyst in terms of identifying, hey, do we have a pyrophoric potential? Do we have combustible materials? Do we have any, known prohibited items? So we're also engaging up with the field folks in terms of what may be happening, so that they don't have to wait until the so-called the complex-wide extended condition review is completed prior to making any necessary changes into or onto their safety-based document.
Okay, thank you, sir. So, Mr. Wyka, what actions or directions is NNSA provided to account for the known deficiencies in the standard, since you guys generate and ship waste too?
Thank you, ma'am, for that question.
Okay.
And first of all, the safety management of waste and storage and processing is a paramount to NNSA, for our mission activities. The timely de-inventory, as you know, of the stored new gen waste from TA 55, Transuranic Waste Facility, as well as Livermore, is critical to not only our current missions, but our future missions, which is the NNSA pit production initiative. So it's critical that we get this done, and it's critical that we work as one team to get it done, because we can't do it all by ourselves. It requires Carlsbad Field Office, their contractor, the labs are required to ensure continuous and efficient characterization and certification of the true waste before shipping it to WIP. So with that in mind, NNSA learned from both events, both from the WIP event as well as from this ongoing event. And it's critical that we take those lessons learned and, again, work as one team, recognizing that the events are distinctly different, but NNSA, and I specifically reviewed the EM safety alert, regarding the April 2018 event. On May 31st, I issued a direction to the field office managers to review the safety alert. This was done via an email. The intent of this direction was to alert the NNSA sites to this issue, first of all, to gauge the potential for occurrence of this type of event, and to consider steps to prevent such occurrence. Now, while the alert is for the EM sites, I think this allows the NNSA sites, it does, to pause and to think about it in terms of our respective operations. NNSA sites are not yet required to provide a written response on the specific actions such as required by EM, but they have been requested to complete these actions as soon as practicable, and that the results would be discussed within NNSA headquarters as part of our New Gen True Waste program review in October of this year. The actions that I specified for them to take on was to first ensure and review the ARP causal analysis report and incorporate lessons learned into appropriate site procedures, as well as reviewing the DOE Standard 5506 accident scenarios against the waste repackaging activities, as well as assessing training of personnel responsible for approving waste for processing and treatment to ensure that they are sufficiently qualified for such treatment operations. Also, ask them to review and update, as necessary, waste operator training materials to ensure modules address the identification of changing waste conditions, i.e. pyrophoric materials, oxidizing materials, and other challenging waste type forms. Of that, to evaluate the existing processes for treating waste in uncertain pedigree, to ensure effective controls are in place to safely handle, package, treat, and stow and waste pending transport and disposal. Also ask them to review procedures for current and future drums with packaged waste to ensure effective controls are in place to prevent or mitigate unexpected reactions, to review radiological procedures for appropriate entry requirements for areas with potential airborne transuranic hazards, and to continue promoting improvement of the safety culture to contributing causes specified in the alert. Recognizing that the department will be issuing an operational alert, which will go department-wide, but NNSA recognizing the importance of our waste management to our missions, taking the actions as I specified.
So that's formal guidance you provided to your generator side?
Yes, ma'am. It was direction to the field office managers, outline providing the alert and providing the context of an application to us, as well as some specific actions for them to take, and that we'd be looking to discuss this as a team at the program review in August of this year.
So that guidance, is that something you could evaluate providing to the right of this board?
Yes, ma'am.
Thank you, Ms. Roberson. Mr. Griffin, I'd like to shift gears a little bit and talk about how schedule pressure may erode safety. You and I are in violent agreement that there's no such thing as perfection in safety, that our goal is to achieve adequate protection. In fact, that's what our statute calls for in the Atomic Energy Act, is adequate protection. So I get that. I also understand that anytime any human endeavor involves some element of risk, and there's also risk for not doing something. And so you have to have a schedule, and the question is, how do you balance that? Could you put up Exhibit 4 and enter it in the record, please? And I'm just going to pause and let you read this please, for a minute. All right. My question to you is kind of general in nature, but I'd just like to understand how you and the department balance production priorities and prevent pressure greater pressure from schedules from eroding safety? How do you balance production priorities with your responsibility as regulator of safety?
Thank you. That's actually an excellent question, and actually one that the philosophy of that area is one that we've actually spent quite a bit of time talking about. And I guess I would start by saying I don't think we see it as a balancing act, but more as a responsibility that we have a responsibility to execute work in the field, and we understand that that's our mission. And so what we have to do is create the processes and procedures that allow us to execute that work safely. I mean, it's a given that we have to go do this work. So how do we go about doing that? How do we create the processes, the procedures? How do we bring in the lessons learned, because things happen sometimes? How do you build that in and continually improve this? So I guess I'm trying to say that I'm not sure we'd see that necessarily as having to choose one or the other, but recognizing that we have to go down this path of executing this mission. How do we build in the appropriate safeguards, processes, and procedures that allow us to do that safely, and then constantly improve that? So that's something that we're continually working at, and both at headquarters with the sites, and I think it goes back to what Dave was talking about earlier, that the safety alert and trying to talk to the sites and get their feedback on this. I'm not sure that completely answers the question, but I guess I wanted to try to get away from this view of the balance there.
Well, Mr. Chung wants to provide some additional information. Please go ahead.
One of the, I think, significant lessons we have learned and we're continuing to learn from the whole ISMS, Integrated Safety Management System, related efforts over the last 2 decades, since the K-reactor restart days, is that we need to factor in safety as part of our business model up front. Whether you're pursuing a major capital project where safety becomes very important from a design perspective, whether safety plays into an important role from a day-to-day work planning and process activities. So I think we fully recognize by now the importance of safety and even quality, that those elements must be integrated into the work, while appreciating the fact that we do have cost and schedule. Without cost and schedule objectives, why have contract, right? So we have our work is being performed by very experienced contractor communities, and we have to establish contractor scope. Within the contractor scope, we have certain milestones. We have cost baseline. We have schedule baselines, and we are continuing to make sure that our workforce understands, not in terms of balancing, but they have to understand and appreciate the objectives of our mission and work scope at hand. At the same time, realizing that the safety and the quality, security even, must be integrated into the work so that they make the right decisions. Therefore, we actually enable getting our mission done more efficiently and effectively. I think that's our goal, and I think that's the goal of the department for the past couple of decades, and I think EM is continuing to strive for that approach, and also making sure that this business about safety base isn't. Some folks think that if you have a very conservative, rock solid safety base, you're good to go, but that is just a part of it. So we need to make sure that our workforce understands not only those upper tier set of nuclear safety related controls, but the importance of integrating hazard or safety into the work. Everyone uses some sort of procedure to execute the work, right? So, and there's a planning process. There's an execution phase. So that's where I think we need to continue to improve in terms of instilling that mindset, as well as the activity level and process level controls, so that the workers who are on the deck plate executing those important work carry those mission and work safely.
Okay, I appreciate that. Let me, just in the interest of keeping us rolling here on time, look at that second bullet again. It talks about schedule pressure was felt by contractor personnel over the entire period evaluated, and that was a year and a couple of months ago. It's just short answer. What's one or two things that have been done in the last 14 months to address that?
If I may.
Just very briefly.
If I may, Idaho Floor actually asked EM headquarters to help them to review their safety culture. So we have provided our own expert from headquarters, as well as some of the well-known industry experts in safety culture area, to go up to Idaho and looked at various facets of the safety culture, not just the program, but through a suite of interviews all the way down to the operating deck. They either reinforce some of the weaknesses. They also found some strengths. So that's one of the actions that both our contractor and DOE have taken to strengthen that aspect. And
Thank you.
then
All right,
Jack may be able to provide any
I think
more
that's-
detailed response.
That's sufficient. Thank you. Ms. Connery.
So I appreciate that, and Ed, we'd love to get a copy of the safety culture report and the methodology by which it was provided, because I don't believe we have a copy of that yet. But my question is for Mr. Wyka, because he looks lonely, and he looks like he was wanting to speak. As the lead for the department's formal accident investigation for the WIP radiological release and the previous deputy manager at the NNSA Los Alamos field office, you're uniquely qualified to understand the multiple factors that contributed to the release. And one of these factors, as we noted, was schedule pressure. In your current role with the National Nuclear Security Administration, which is under schedule pressures to accomplish its many national security missions, can you discuss NNSA's approach to avoiding the negative effects of a challenging schedule, particularly with respect to wastes, which can receive a lot less attention compared to weapons components?
Thank you, ma'am, for that question. And as I previously mentioned, the management of waste, from our perspective, is just as important, as the mission, because we need, for us to do our mission, we need to be able to remove waste, from our generator sites to make room in terms of MAR as well as in terms of storage. But, balancing the mission schedule and safety at generator sites is critical. And, in response to the previous question of what new activities can we do, it's probably doing the old activities and implementing, those effectively. And that's dating back from the board's recommendation 95-2, integrated safety management. And it's that balancing the schedule and the safety and making safety as a critical part of the mission. So the NNSA generator sites constantly strive to balance that mission with safety through establishment of challenging and yet achievable goals in the True Waste contracts. That's our vehicle that we use. There's a strong partnership to ensure that the mission goals and safety are intertwined, as outlined in the department's expectations for integrated safety management and for a strong safety culture. And it's something that you have to continuously look at, because when you think you have a strong integrated safety management or safety culture in place, you're looking for those weak signals where it's degrading, where you're backsliding a little bit. So these expectations are clearly defined, in our prime contracts, and the workers at the generator sites are well versed on the hazards associated with the work and are involved in the development of controls. But it's to maintain that pressure of continuing to strive for improvement with integrated safety management system, safety culture, as a critical element of getting the work done, of completing the mission. And they prevent or mitigate consequences from the hazards and are comfortable with the controls established. These are the workers to protect the workers, the public, and the environment. So it's the actual and effective implementation of integrated safety management, continuing to build on that. And we saw that in both this current event, the WIP event. Some of the contributing causes are similar. the mechanisms may have been a little different, as well as most of the other, events. If you dissect them and look at the contributing causes past the root causes, it's, again, effective implementation of, those systems that we have been trying to and continue to put in place for the last, 20 years.
Thank you.
Thank you, Ms. Connery. Ms. Roberson.
Thank you, Mr. Chairman. So, first of all, congratulations, Mr. Schrader, on your more recent assignment. But in light of your previous role as Carlsbad manager and other roles in the complex, can you describe the division of responsibility in the environmental management program relating to ensuring safety of waste from generation to final disposal?
Sure. I think Mr. Griffin alluded to this in his opening remarks. The programs and processes we put in place after the WIP event were specifically put in to protect WIP, and these would be enhanced certification processes such as enhanced acceptable knowledge reviews, chemical compatibility evaluation reviews, base of knowledge reviews where we look at oxidizers, nitrates, et cetera. All of that is intended to ensure the waste prior to putting into a shipping container or true pack, and prior to the shipping at WIP, is going to be safe there. That's been enshrined within our DSA, in fact, a new Chapter 18, and we were the first in the complex to have that, a specific waste management chapter within the DSA. That ensures that the work done at the sites as the waste is prepared ensures that WIP is safe. Moving upstream of that, the site itself is responsible for safety at the site. For instance, they have their own DSAs for, say, a true storage facility. They have their own permits, for instance, for RECRA compliance, that type thing. We define those through memorandums of agreement between the site and the Carlsbad field office, where we specifically call out what those divisions of responsibilities are. We also have the site certification process, where we send a team out to the site, look at the certified program, and ensure that it's meeting the requirements of our permit itself. When that team is satisfied that the permit requirements are being met, the Carlsbad field office manager certifies the site for shipment. And then we have a third piece that we think helps in both sides of the equation, the generator site technical review. This was a new process put in place after the events, where it's going to look at not the certified program and permit compliance, but general processes and work done at the site. It's built around giving assurance to the manager of the Carlsbad field office that the site has rigorous procedures and processes in place to ensure safety of the waste coming in. But at the same time, it also gives some lessons learned and some issues that the site can use to improve the safety at the site itself also.
So that was, I think we are going to have questions. We're going to talk about the technical reviews later, but based on your experience, can you describe some of the challenges that you have seen in making sure that waste is acceptable for risk as early in the process as possible?
Sure. I think it's been alluded to a couple times here. Legacy waste, of course, is our most challenging waste. And that's because the paperwork or the acceptable knowledge and the history of that waste is often not as detailed as it is today. And it's because some of the waste was generated 30, 40 years ago. So our challenge there is to go in and expand how we look at the waste and look at the documentation. You don't look at just, for instance, when you're looking at chemicals, potential chemicals in waste, you don't look at just what the process was. Were there other chemicals used in the buildings? What were the other processes used in, say, a glove box, Rocky Flats, for instance? And so that's how we address those challenges. Is by far the biggest is just, do we really understand what the waste is? And that's where we expand our reviews of the documentation and the history of the waste. And it gives us, once we do that, we think we can build a much better, more comprehensive, what we call acceptable knowledge package, which is a combination of all the documentation to describe what the waste is.
And are there other potential actions that could be taken to ensure that the process from beginning to end is safer or more efficient? Or is that pretty much encompassed?
No, if in certain cases you may get to the point where the acceptable knowledge or paperwork simply is not sufficient, and you could go into a sampling analysis regime if you needed to for certain waste streams to build your higher level of knowledge for both safety and, frankly, RCRA compliance, also compliance with our permit. Further upstream of that, some of the things that we certainly help with legacy is I think we talked about the lessons learned process, both the formal process, the safety alert that was alluded to earlier, and even the informal processes we, the Carlsbad Field Office, have, where we communicate with all the sites on a bi-weekly basis, all the true generating sites of lessons learned and things we've seen, and maybe they can incorporate into how they do operations also.
Okay, thank you.
Thank you, Ms. Roberson. Mr. Schrader, you're on a roll, so I'm going to stay with you for another minute here. I'd like to talk about how the learning that individual sites is translated across the complex. We understand that one of the department's prominent corrective actions taken in response to the WIP event was to establish a generator site technical review process to ensure that waste is acceptable at WIP. This process uses experts to review whether processes and procedures are in place at generator sites to ensure that the transuranic waste meets the WIP acceptance criteria. I'd like to enter Exhibit 5 into the record, please, and I'll just pause and let you read that for a moment. Our staff reviewed several of these reports, and we found that some issues were common across multiple sites, and you can see them up there. Can you tell us how you identify and address deficiencies that are found at an individual site that turned out to be common over multiple sites? How do you translate that into policies and procedures across the whole complex?
Sure. So I'll take the second one first, this issue of worker knowledge. Oftentimes that may not translate into necessarily a safety risk. It may translate into a efficiency risk. And by that I mean there's a certain amount of knowledge we look for as we certify transuranic waste, what the process was, what the documentation, et cetera. By ensuring workers have knowledge of where the information is going to be used earlier, it can increase efficiency down the line. How that's translated to the sites specifically is, again, we have our calls with the sites every couple weeks where we have specific lessons learned we can apply. We also have about every 9 months we have a generator site meeting where all the sites come together. The next one is in Chicago at the end of July. We have very specific sessions on that about common areas, common issues we've seen in GSCRs, lessons learned, and so that's a good chance to bring all the sites together and talk to them about here's what we've seen in multiple sites around the complex, and we can pass that knowledge on at that point. The first one is similar. Some of that, the absorbents or some of the chemicals information we knew, that will sometimes translate into the certified program where we'll have very specific questions that we'll look for specific waste streams based on what we see there also. So that goes into the certified program review of the sites.
I would think that certainly you wouldn't wait until you have a conference in Chicago if you found something that was
Certainly
relevant to all the sites.
And that's why I mentioned we have a call every 2 weeks with the waste generator sites. It's led by my assistant manager for the National Transuranic Waste Program. All the sites are on it, and that's a common place that we can talk about this. And if it were truly to rise to a high enough level, we can always use the more formal mechanisms the department uses, such as the safety alert system or operating experience, et cetera.
Okay, thank you. Mr. Griffin, would you like to add anything to that? You don't have to, but I know this is in your lane.
No, I think I would have said exactly what.
Okay, that's
what
fine.
Todd says.
I just wanted to give you the opportunity. Thank you. Ms. Roberson.
Excuse me. Okay.
So I just want to clarify, though, because the True Waste Program is not it's not a reporting chain from the generator sites. So they're both. It's more of a customer service relationship. So I understand that that is a good way to send information informally that that good generator sites will adopt because it's in their best interest to do so. But there's really no mechanism, as I understand it, for the National 2 program to require anything from the generator sites except for as it applies to the waste acceptance criteria. Is that a true statement?
Yes, but the waste as a general statement, I agree with that. But the waste acceptance criteria can have fairly expansive requirements in it. If we truly found an issue that was being an issue at multiple sites, we can revise the waste acceptance criteria. That is now becomes a requirement for all shipping sites to send to us.
But those requirements would only take place prior to shipment. So while that waste is at the generator sites, you wouldn't have any way to influence that.
Correct. The National True Program's boundary is at the certified program, not at storage at the sites, et cetera.
Okay, thank you.
Thank you. Ms. Roberson.
So I just wanted to bound the generator site technical review process, which is a tool that you use, and a good tool, but my understanding is limited in scope. And so there was a technical review done at Idaho before the event, and we had the exhibit up. It pointed to certain things, but it didn't alert or preclude the event. So are there improvements planned to that process or other augmentation? For instance, is there any thought given to independent evaluation for the potential of chemical reaction events at generator sites?
The generator site technical review process is a programmatic review, and so it would not necessarily detect individual waste stream problems or problems in individual drums. But saying that, after that event, we are certainly always looking to expand or improve, improve the generator site technical review process. I don't have the specifics now, we're talking about it, but if there are areas we can find, particularly to address common issues around the complex, we would certainly bring that into the GSTR process. Again, I would also mention, if there's common lessons or common issues, we do have the more formal processes within the department that we could also engage, and Mr. Griffin has spoken of those also.
Thank you.
If I may add, if I go back to the safety alert that Dave discussed earlier, I think as he outlined, the idea would be that we go collect this information and then sit down, or not sit down, but get with all the sites and figure out how this translates into impacts across the whole program, including the site technical reviews, the generator site technical reviews.
So don't turn it off. Yeah. So I just want to clarify. You're expecting some form of that data in around September. The executive leadership is going to look at that, and there may be additional processes or requirements as a result of that. Is that what I understand?
Absolutely.
Okay. Thank you.
Did you want to add anything?
Just the only thing that I did I did mention about the not only the required actions but recommended actions. We do have established process for communicating issues. We do have either monthly or quarterly site briefings that we have been conducting for several years, and we have identified that as an example for communicating any issues from even this safety alert related information gathering effort, so that there are multiple mechanisms, I believe, that where the field can let us know what they're finding, as well as ability for us to be able to ask questions. So just wanted to add that.
Thank you.
If I could add as well, at least it was mentioned that as the deputy manager for a generator site, I found the GSTR reviews very helpful, especially looking at the lessons learned from the other reviews and improving your programs, because GSTR actually looks at, you know, wide area things such as a QA program, the generator site assessment program, an issues management program, which is a problematic across the enterprise, you know, our conduct of operations as well as our federal oversight, and the waste management program itself, including the generation piece, the treatment, packaging processes, the permitting aspects, and then the hazardous waste determination, all critical elements, you know, as well as the deferred maintenance. So I found that as a deputy manager useful not only for the True Waste program, but you know, across the site in terms of program, because of the programmatic pieces that it looked at.
I appreciate that, and I thank you for that. And I, as I'm sure the rest of the board does, looks forward to see what comes of the effort you're taking. I guess the only thing I'd say is, yes, there's been 2 events. There's a history of events, but I think through this effort, it looks like the recognition is it isn't the event that's the anomaly. Sometimes it's the waste that's the anomaly, and trying to figure out how you equip yourself to handle that is very important. Thank you.
Thank you, Ms. Roberson. Board Member Connery?
Got to get used to this microphone thing. After the WIP event, there was an extensive federal accident investigation, but there wasn't one at Idaho. And the contractor's formal causal analysis report does not, and I quote, include evaluation of DOE's actions or contributions leading to the event. In fact, after our analysis, we believe that deficiencies in Standard 5506 could have been a contributing factor to the event as well. So I'd like to know, now that you've issued the safety alert, and I understand you're going to get a lot of information that we will find relevant to our questions of about a month ago, how are you identifying corrective actions for the department itself or for Idaho Ops based on the event, given the fact that you didn't do a federal investigation?
If I may answer that question. Idaho Field Office, along with the EM headquarters, have discussed the options that we had in terms of whether or not this event, based on the knowledge that we had at the time, would trigger an AIB type of investigation, or could we do something else? So we examined the criteria that are given in the governing order, 225.1b, in terms of, so we considered those factors very carefully. It did not trigger any of those criteria, including the financial or monetary aspect at the time. But both contractors and DOE recognize that finding the technical root causes is going to be essential part of this, whether you want to call it investigation or review. So we decided to have the Fluor Idaho to lead the investigation, but with a very strong oversight from both DOE Idaho and EM headquarters. So that was our collective decision at the time. And then by working with our contractor, Idaho Fluor, we have broken the investigation into 3 different groups, if you will. There was a group that focused on causes. Also, there was a group that evaluated the responses from firefighters and whatnot. We also wanted to make sure that the corrective action plan development process was sound and rigorous. So, and then Idaho Field Office, under the leadership of Jack and Mark Brown, put together a very strong team in the order of about a dozen SMEs to provide individual attention to each one of those functional areas that I mentioned, the 3 of them, as well as the several important functional areas, including root cause analysis, fire protection, work planning and control, accident investigation, occupational safety and industrial hygiene area, operations, waste management, environmental compliance, radiological protection, and nuclear safety. I would say that was pretty thorough coverage in terms of their oversight. In addition to Idaho's oversight, EM headquarters provided a significant oversight. We'd had a chief engineer at the time to very deeply engaged in the discussions of the chemical reactions and the chemistry surrounding the event. We also provided expertise in nuclear safety, conduct of operations, and radiation protection. As I mentioned earlier, we also provided, at the request of the field and the contractor, a very strong team, including industry experts, to look at the safety culture program. And also, during the development of the corrective action phase, which took a while, I seem to recall seeing a draft coming out back in December of last year. 3 or 4 of our headquarters staff working with Idaho federal colleagues, we have extensively reviewed that. And I don't know whether the board has seen the record of our comments, but it's a very extensive set of comments, which we believe help the contractor to come up with a pretty good set of corrective actions. The other thing that Idaho and we decide to do in terms of looking at Idaho's federal oversight, two experts from ORP, Office of River Protection, and one senior person from EM headquarters were put together to look at the federal oversight program at Idaho. They provide a 30-page report. They basically concluded that the oversight was adequate. However, they point out certain recommendations, which Idaho is either have completed most of them or in the process of completing most of those recommended actions. So if you look at the rigor and the depth that the contractor have done in terms of their technical root cause and the also resumption effort related investigative work, I think there was pretty comprehensive investigation. Along with the DOE oversight provided by Idaho and EM headquarters, I think that we have done a pretty good job of not only identifying root causes, but also all the relevant contributing causes, as well as pretty responsive corrective action.
I'd like to add on to that if I can, especially with experience as the Accident Investigation Board Chairman for both the salt truck fire as well as the drum event, but probably more importantly with my current hat as the Cognizant Secretarial Officer for NNSA. I'm the one that directs the accident investigations for NNSA. I've had the chance of directing 4 actually within the last year. Using the DOE standard 225.1, and my main trigger for directing these events is really, can we learn anything? And can we learn anything that's going to, help the enterprise, not only in NSA but department? And there's really there's different mechanisms to do that. In fact, I've used 3 different mechanisms in chartering accident investigations. I've had 2 where they were complete federal teams. I've had 1 where it was a combined effort. It was a combined federal as well as contractor team. And I had 1 in which I had the contractor lead the investigation, and I assigned a federal monitor, to look at the deliberations of the investigation as well as a team to do the federal oversight piece from both the contractor as well as the federal component. And all 4 of them have been just as successful. And in terms of their rigor and in terms of the depth, in terms of the conclusions of the root causes and contributing causes, and all 4 have been briefed to the administrator. So there's different mechanisms for doing accident investigations. The key is management attention, on these investigations, and making sure that they have the tools to successfully do what they need to do without any interference, and that you're looking at all aspects of it, as well as all the oversight aspects, both from the contractor, the parent organizations, as well as federal organizations.
Thank you. I actually appreciate that explanation. I would just note that the field office at Idaho, that federal oversight review actually took place months before the contractor event investigation was concluded. So I'm not sure that it was as helpful because it was completed before the causes of the Idaho event were thoroughly understood. But when I asked this question originally, and I asked it back in May of last year to somebody who's no longer working at EM, I was told that the reason that they weren't wanting to do that, in addition to the fact that it didn't reach the financial threshold, was the fact that they didn't have the federal resources to conduct such an event. And so I'm curious as to whether in the event that there was something else that happened in the future, would you have the resources, and by that I mean the talent was I think what that individual was getting at, in-house to perform a federal accident investigation on the EM side? I understand the capabilities of the NSA side because I came from them, but I don't know whether or not EM, from what I've heard, would have that capability, and if that was really one of the causes of not doing a federal accident investigation, that's troublesome, and we would want to make sure that you do have the resources to be able to do that in the future.
My position at the time of this particular incident was I was acting EM3 as well as Special Projects Office Director, so I was aware of the incident, and I was engaged with Idaho DOE leadership in terms of deciding whether or not federally led AIB would be needed. The lack of resource was not a factor at all, as I recall. So we still have enough talent at headquarters as well as in our field offices to be able to conduct very high quality and reliable investigations. We thought that the method that we chose would result in a satisfactory investigation, and more importantly, as Ted said, that we would learn from it. And then we wanted to make sure that Idaho's oversight program was okay by bringing in ORP colleagues to look into that, because that gives them an opportunity to learn about various processes and whatnot. So,
Thank you. I appreciate that.
Thank you, Board Member Connery. I'd like to address this to you, Mr. Griffin, and maybe a follow-up to Mr. Wyka. Let's talk about current federal oversight at the generator sites. I'd like to enter Exhibit 7 into the record, and I'll pause so you can read it. This exhibit notes continued heavy reliance on your facilities representatives to conduct federal oversight to protect the waste isolation pilot plant, including oversight of chemical reaction hazards. So could you please discuss whether you think the facilities representatives are the appropriate personnel to provide oversight of the chemical reaction hazards, and maybe expand that to talk about whether you need other federal subject matter experts to perform this oversight?
Yes, I'll do what I can. So I have to say that I've been within the department for 8 months, so some of this precedes me. But then also that does provide a perspective, right, from coming from outside a national lab background. And so I have to go back and echo what Mr. Chung was talking about. My sense, and I have, this is one of those areas in my current responsibilities that I would have great concerns over. My sense is that we do have a very strong, technically capable organization that has the capabilities to do the kind of work we're asking them to do at these sites relative to, at the sites and the complex as a whole, relative to the National True Program, the generator sites, and the Crossbed Field Office. It's a well-trained staff. They're generally very familiar with the issues. They're qualified. And we have technical resources, great technical resources within, not independent, but within the contractors as well as the national labs, and we don't hesitate to draw those resources in. So I don't have a great many concerns in that particular area. I mean, you're always concerned about an organization and managing it for the future, and so of course that's something that we continue to talk about. Relative to this specific question, I'm not sure that I can speak very knowledgeably about it. I'd ask Day or Todd if they want to.
And before you do, and I'll let them do that. But
Okay.
Before you do,
Yeah.
and I understand 8 months on the job, but also understand that sometimes a new broom sweeps cleaner. So again, one of those balancing things. But have you ever considered updating the qualification requirements for any of these federal positions? Is that, and a yes/no could be.
I think those kind of discussions are on the table. Yeah, I mean,
Okay.
so we'll be looking at that as we go
And
forward.
I'll go ahead and open it up to Mr. Chung and Mr. Wyka. Go ahead.
Let me address it from
Sure,
at
go
least
ahead.
an NNSA perspective,
Go ahead.
because this is a very important question. And it's a question that deals with everything that happens right and everything that happens wrong. You know, whether it's waste management or whether it's a shipping container that shuts things down for a prolonged period of time. And of course, all of that sort of affects mission. So let me sort of discuss in terms of the quote up there, the facility representative, great individuals, very well qualified. They are the tripwires of our oversight program to identify, issues, and they're there because they had that questioning attitude, and very, very valuable to me as a deputy manager at Los Alamos, as well as the CSO. But for this, for oversight was a really basis for your question, and you have to really look at it at all levels. And I'll try to talk philosophical from an NNSA perspective, and then the technical qualification program, which is a big key with that, as well as sort of focusing on the waste management activities. As you know, I think you were briefed on it, and NNSA is developing a safety roadmap. There's nothing really new in that roadmap. It's really a collection of things that we have developed, sort of as a department. And we are working our oversight process improvements employed with our management and operating contractors, through this roadmap. So it's something that we're building together, recognizing the limited resources that we have, and also the resource challenges on the M&O contractor side, especially with our increased mission growth. The key most initiatives of this roadmap, and again, this is a higher tier before getting down to the waste management program, but it applies, is standardizing the process and the technical qualification program, which, as well as the safety basis review processes in the way we do those things. We're working towards an NNSA, first of all, NNSA enterprise-wide TQP. We accreditation program rather than accrediting individual sites. We're accrediting the entire entire NNSA program, all program office, functional offices, as well as site offices, to ensure we had that base technical qualifications to do our respective jobs. And also using safety basis review teams to leverage the federal resources across the enterprise for consistency. And that's really valuable, especially for me as a deputy manager, looking back, because you have the opportunity to use resources across the enterprise to look at your safety basis issues, so that you don't have the same eyes looking at the same issue over and over again. So it's even if you had unlimited resources, I would still want the use of resources from other sites to help us in that area. Roadmap also uses modern tools and data science and integration to organize information for accessibility and transparency, and that's going to be key, is the data and analytics piece, recognizing with our resource limitations, to be able to, that transparency of flow of information, from the M&O contractors to the field office to the headquarters and across the enterprise, is very valuable. It's very valuable in our infrastructure program, where we built that trust where we share information. Same thing on the safety side, which again gets into the oversight of activities, and then employing correct visual management tools, the metrics, and working collaboratively not only with the field office as well as the M&Os, to develop what are those critical metrics that tells you something about performance, confidence in the information, risk, and consequences, and something that we're using as a team to leverage the resources across the enterprise to swarm those issues where we need to swarm. TQP, as I mentioned, is we're working towards an enterprise accreditation, and this is again to ensure consistency of the technical capabilities for employees in the technical disciplines, as well as enhance the pass down of acquired knowledge from senior staff. Especially with our retirements and losing folks, it's very important, to have a strong base program like that. This accreditation program is going to include an independent review of the NNSA programs, confirming that we've established qualified training programs, qualified trainers, that we have a strong oversight in the program and formal feedback evaluating M&O performance within our technical qualification program. And that'll be done by an independent office by AAU. We did a self-assessment already. We're doing pretty good in terms of field offices. Headquarters, we're making significant improvements. We'll be ready for accreditation by about the August timeframe. Now, implementing NNSA governance, which is the next piece of this, after the roadmap, is is the governance, which we have been implementing since 2017. I know the board's been briefed on that. NNSA continues to implement and mature its site governance program in accordance with 226.1 Delta. The goal of governance is to set expectations for the M&Os, federal field offices, program office, functional offices, that govern our nuclear sites, and to leverage the M&O assurance systems, contractor assurance systems, enabling federal oversight so that we can focus on the higher risk activities, including the waste management and the National True Program. And this is, I think, resulting in more effective M&O performance and federal oversight. So that's the higher type layers. Looking at the True Program itself, for true waste activities undertaken at generator sites, increased emphasis is placed on assurance that the WIP-WAC will be met prior to receipt of waste at WIP. And parts of this assurance is enhanced by the chemical capabilities evaluations that was previously mentioned, the added emphasis on the basis of knowledge, which is a key piece of our collective enhanced AK program, and enhanced reviews and oversight of the certification of WIP prior to shipment to WIP. And at the generator sites, this also includes appropriate evaluation of activities at the generator sites, appropriate hazard evaluations, establishment of controls to protect the activities at the generator site. And we have a team at, not only at headquarters, but our field offices, and we use our TQP program to make sure they have the required base knowledge for doing the jobs, that they're doing, as well as transferring a lot of the experience, from those that we have in place now to, the staff as they come in. It's not just the facility representatives. It has to be the entire program, and the facility representatives are a key piece of that program.
Thank you. Very, very briefly, and I want to put up the second slide here, and just let you have an opportunity to look at it. And I don't present this as some sort of a got you. My point is that 2015, this was shown to be a challenge, and then here in March of this past year, we see the same sort of thing. So 3 years later, you still have these continuous weaknesses, and I recognizing what you just said about the process and practice that you've got going on. Is there anything else that you specifically want to address this 3-year lack of a positive trend?
Thank you for the question. Good question. This is where you need the system and you need a questioning attitude, because the facility representatives don't have to be chemical experts to stop these incidences. Because if you look at the contributing causes, most of them were, decisions being made, that weren't well thought out, changes in procedures without appropriate reviews, changing constituents, and pieces going into the drum without the appropriate reviews. And these are all the questioning attitudes. So by establishing that environment of the facility representative being able to stop, pause, question, maybe without being the technical expert on the chemical compatibility issues, but it's them doing their normal job, but it's creating that environment from the top down, and that's why I went through all the layers of oversight to allow them to make those calls on on the field, to be able to make those questions, to look at changes in procedures that haven't been reviewed by appropriate sources.
Okay, thank you. I think that's sufficient to address my question. Did you want to add, Ms. Roberson?
Well, I wanted to push back just a little bit. I understand what you just said, Mr. Wyka, but I would say even a change in procedure, I mean, to some degree, these events do require a certain degree of sophistication and understanding chemical interactions. And I would say you have very talented, very smart facility reps, but it isn't just them being on the front lines. Who's to back them up? Who are they to call? Who are those people and where are they?
You're absolutely right, and I'm glad you made that clarification, because it's the team. The facility representatives are those that sort of see, smell, hear different things that they may call into question, and they need to have somebody to go to, subject matter experts in those areas, whether it's an electrical safety event, whether it's a chemical compatibility event, or whatever, to go to have to allow the team to drill down on this issue that was identified by the facility representative. But the facility representative themselves, what I was trying to sort of mention, it doesn't necessarily need to be an expert in every area. They just need to have that mature questioning attitude to take it to an expert that they have that is available to them. It doesn't necessarily need to be at the site. It could be at another site where we leverage resources where appropriate, or as well as at headquarters to drill down on a specific issue that was identified.
Do any board members have any last questions for the panel before we take a break? Seeing none, thank you very much for this first session. We're going to take a 15-minute break and restart at 2:05. I'll point out that the clocks in this room appear to be a couple minutes slow, so just look at your phone. We will recess now for 15 minutes. Thank you. This time I'd like to reconvene our hearing for Session 2. In Session 1, we failed to enter one exhibit into the record. It was exhibit number 6, so I'm entering that exhibit into the record now. Did we already show it, or did I just?
We did show it.
Okay, thank you. So Exhibit 6 is formally entered into the record. Our goal for this panel is to gather information on safety controls, to address the vulnerabilities associated with handling and processing solid nuclear waste at defense nuclear facilities. Our panel is the same as it was for Session 1, except that instead of Mr. Todd Schrader, we have Mr. Jack Zimmerman. Welcome. Mr. Zimmerman is a deputy manager for the Idaho Cleanup Project at the Office of Environmental Management. Thank you for being here. I'm going to start out again with our technical director, Mr. Rossetti. During the first session of the public hearing, we discussed the programmatic requirements and federal oversight responsibilities for solid nuclear wastes. This second session will focus on operational execution and safety controls for processing solid nuclear wastes at individual sites. Would you please provide an overview of the department's response to the February 14th, 2014 waste isolation pilot plant accident?
Yes, sir. Mr. Griffin provided some of that information in his opening statement, but I will try and summarize more here. In response to the WIP radiological release, the department conducted a comprehensive accident investigation that identified multiple judgments of need. Several judgments of need were related to strengthening confidence that waste is adequately characterized and compatible from a chemistry perspective. The department's primary corrective actions in this regard are more rigorous activities and processes to ensure that the waste being shipped to WIP is acceptable to WIP. Even before the February 2014 event, WIP had a document called the Waste Acceptance Criteria, or WIP-WAC, which define the requirements for sending waste to WIP. Following the February 2014 radiological release event, the department made some improvements to the waste acceptance criteria. These improvements included measures to collect better information about the waste being shipped to WIP. The department now uses this information to perform an enhanced chemical compatibility evaluation. The waste acceptance criteria must be met before waste can be certified for shipment to WIP. However, this means that generator sites may handle and store waste containers for extended periods of time prior to demonstrating that the waste contents meet the new requirements. During this period of time, the generator sites rely on their own processes to ensure chemically compatible waste. Finally, as we discussed in the first session, the department also initiated the generator site technical reviews, or GSTRs, following the WIP event.
Thank you, Mr. Rossetti. Board Member Connery.
Thank you. Mr. Rossetti just described that the environmental management generator sites are required to meet the waste acceptance criteria. That's actually hard to say. The WIP-WAC before shipping waste to the waste isolation pilot plant. Mr. Griffin, we've heard both in the first session and in Chris's description about the WIP-WAC and those criteria. Can you describe any other significant measures that were taken by the Department of Environmental Management generator sites in response to the WIP accident for the purposes of preventing accidents at those sites? So not at WIP, but at those sites.
Well, yeah, I think actually some of this was covered when in the earlier session when Mr. Schrader talked about the kind of and I mentioned also the comprehensive set of activities that we put in place. So, you know, we have as you discussed, it's just outlined by Mr. Rossetti, the WIP-WAC, and then we have the generator site technical reviews that we put into place, and the certification, the strengthened certification program with enhanced chemical compatibility evaluations, the acceptable knowledge, enhanced acceptable knowledge, enhanced basis of knowledge for this. So I believe that we pretty well covered all that. I don't know whether Mr. Zimmerman would like to add more to that based on his experience of being at a generator site.
Yeah, I can speak for some of the actions that were taken at the Idaho site. And in particular, you know, and I imagine many of the other sites did something similar because, as I recall, there was some guidance from headquarters at the time to take the Accident Investigation Board report from the WIP accident and basically evaluate that for your site and look at what the appropriate actions are. So primarily, for Idaho, we directed the contractor to review the report and conduct an extended condition review as it applied to their activities and take the appropriate actions to prevent recurrence of similar type events. In Idaho, the response from, at the time, we had two contractors because the mission was kind of split. So went to Idaho Treatment Group, who was primarily dealing with the stored above-ground transuranic waste, and also CWI, who was the contractor responsible for the buried waste. Both of them largely came up with essentially some of the same set of actions, but for Idaho, it was really focused on strengthening the procedures that would prevent the inadvertent addition of incompatible materials similar to the root cause of the WIP event. And additionally, they continued efforts to ensure that they had strong employee safety effort through the voluntary protection program, as well as periodic evaluations of their safety culture. Also, as part of that initiative, they made sure that they communicated the results of the WIP event, so they basically educated the workforce on what happened and what the consequences were, so that there was a general employee awareness associated with that. And with Fluor Idaho, they continue to maintain a VPP star status site with regard to and they also conducted a safety culture assist visit that really found a strong safety culture at the site. Well, what that really did was prove that really just one weak link in your safety culture can have very significant impacts.
So just to follow on, so during the first session, we talked about the WIP event basically showed that the magnitude of the release could be greater than postulated and greater than previously expected. So logic tells us that if DOE sites analyzed the larger releases for postulated events, then the estimated consequences could have driven them to implement greater controls. And specifically, I'm talking about the release fraction that wasn't necessarily adopted in the safety bases across the sites. They were only adopted at WIP and maybe one or two other EM sites. So can you talk about why or whether it was considered to update those release parameters and whether or not additional controls or defense in depth were put into place because of the potential for that type of release?
Yeah, we were already using conservative release fraction values that were consistent with the larger numbers that were recommended, so there were ultimately no changes in the consequences of the evaluated events in Idaho.
Mr. Griffith, can you address it for other sites and across the environmental management program?
So I think, as I said earlier, that some of this precedes. I do not have good insight into the thinking that occurred at that time. So it was back to 2014. So rather than trying to speak out of school on that, I'd really rather to defer to today on that.
I was also absent from those days when folks were busy working on the. Anyways, but having read most of the lessons learned documents, including the operating experience, the letter of recommendations, and various responses from the sites that were asked to evaluate potential impact, particularly with the nitrate salt being commingled with organic absorbents and whatnot. The two, as I mentioned earlier, there were two sites that responded positively, WIP obviously, but also Los Alamos. So those two sites are where they have applied the value for both airborne release fraction times respirable fraction of 0.205, which is greater than what had been typically used in the complex. So that was corrected at those two sites. The rest of sites responded negatively in terms of the need to apply higher release fractions.
But
having said that, if you look at, I'm sure we're going to get into more details on ARF 5 event, but not only the potential consequences are important, but what is the estimated frequency or likeliness of chemical reactions or deflagrations or overpressurization events could occur. So that comes into play in terms of selecting your safety significant controls. Because typically when you go through hazard analysis process and you're looking for those bounding / representative scenarios, you go through what is known as a risk binning process. So where they look at the likelihood of certain event happening as well as the potential consequences. So in the case of ARF, the ARP event, the consequence was evaluated to be still bounding. However, they through their PISA and USQD process and associated safety evaluation process, they identified that that type of event could occur more frequently. So they changed from unlikely to anticipated. However, because of the fact that they already screened in from the previous analysis, they didn't have to change the safety basis level controls based on the risk binning. However, as Jack may want to talk about more detail, but they did add, as part of TSR, a couple of programmatic or specific admin controls to restrict the operation so that they can deal with potential pyrophoric and other types of chemical reactions in a much more reliable manner. So that's how I think we have learned lessons from both WIP event as well as the R5 event in terms of release fractions, as well as how do we make sure that we end up selecting the right set of controls through the hazard identification and analysis process.
I understand. I understand what you just said because I've been studying this for a while. But just as we go through this, it'd be helpful if you note when those changes were introduced, because the changes that you spoke of were introduced after some of them were introduced after the Idaho incident. So they were not preventative of the Idaho incident because it didn't exist until after the Idaho incident. So I would just be very careful of the timeline of this, because that's what we're trying to get at, is why after the WIP event some of these precautions weren't put into place, some of these release fractions weren't taken into consideration that could have prevented and mitigated the accident. So if you're speaking in generalizations of things that are put in place after, that doesn't really help the conversation.
My point being that the operating experience document specifically identify nitrate salt issue. Okay, so that when that was distributed throughout the complex, I do believe that the January sites have adequately responded to the OE concerns. Having said that, if you look at the 5506 standard, it does say that you need to evaluate certain accident types. They were selected deterministically, not necessarily based on a significant level of hazard investigations or analysis. We decided that these are the typical types of accident types that you must analyze. Container deflagration, multiple container deflagration, pressurization events. They were told to analyze those regardless of likelihoodness from a consequence determination standpoint. That was the philosophy that was built into that standard. And then basically applying the release fraction data that had been used for a long time. The 3010 handbook was basically brought into that 5506 standard as a standard means of selecting or using release fraction related data. So the fact that we have learned from the very chemical reaction phenomenon from the WIP, I think the department did the right thing by telling the complex that you got to be careful in terms of the nitrate salt and other organics. So that was dealt properly in terms of using the higher release fraction. But that does not necessarily mean that the standard had to be revised.
You're in the middle of revising the handbook right now, aren't you?
Yes,
Okay.
but not just because of that.
Mr. Rossetti?
So I'd just like to make a point from the board staff perspective, because we're talking about WIP and nitrate salts, and we're talking about Idaho and overpressurization, potentially deflagration, and we're talking about the release fraction. So for people who may not understand, when we're talking about a drum, there's a certain amount of material that's in a drum. The release fraction is a value that is used to calculate how much material potentially could come out of that drum given an accident. So whether it's nitrate salts or whether it's an overpressurization event, if you're using a smaller release fraction, you're estimating that the amount of material coming out of that drum in an accident is going to be less than if you're using a larger release fraction. So from the board staff perspective, we're looking at across the complex, regardless of the cause, whether the department is using an appropriate release fraction to estimate the appropriate amount of material potentially coming out of a drum in an accident.
Thanks, Mr. Rossetti, for that clarification. I'm going to yield my time back to you all since I'm not seeming to make any progress right now.
Ms. Roberson.
So I'll just add one comment, and Mr. Rossetti can certainly jump in. The airborne release fraction we're talking about, 0.205, is not our number now. That's the department's number. So we're still, as Mr. Rossetti said, we're still looking. We don't know if that's the right number or not, and it is very limited. But taking the same question and going to NNSA, you talked to us earlier about something you've done since the Idaho event. What did NNSA do, or what kind of direction did it provide to its generator sites in response to the waste isolation pilot plant accident for the purpose of preventing or mitigating accidents at those sites?
Thank you, ma'am. We did, extensive training, obviously, on the root causes, all the contributing causes, all the programmatic breakdowns, and process and procedure oversight. But specifically, like for Los Alamos, the safety basis documents, all the safety basis documents were evaluated and revised for the remediated nitrate salt containers. We went through an RNS drum campaign for about 6 to 8 months, and was able to remediate successfully without incident all of those drums. The Wyka facility implemented restrictions on the use of organic kitty litter to prevent an exothermic reaction. We did significant operational control improvements were made, including renewed attention to procedures, ensuring compliance with the whip rack during drum filling, as well as validation of contents through records, verification prior to shipping. At the landfill, a lot of significant safety basis changes in retrieval, transportation, processing of RNS drums, containers, and we used to develop a suite of safety controls that would prevent a similar type reaction. The other thing we learned from the and what was changed as a result of Phase 2 review was the uncertainty of the AFR and RF with values with respect to POX. I think that was a collaborative success story over the last couple of years, where we did significant subsequent fire tests complete at Sandia on tested filters, which ultimately determined where the DR was ultimately determined to be 0. The new filters were manufactured and made available at Los Alamos. I think we replaced 740. We have about 124 to go. We completed all 150 changeouts at Livermore, 150. So with the new filters in place, all the parameters used in the 5-factor formula for calculating those consequences in the DOE standard 5506 are correct. In fact, we're in the process now of beginning shipment of some of those POC containers, which again will have a significant mission impact for an NSA.
So, how many NSA facilities have revised their safety basis to account for the increased magnitude of the release from an energetic chemical reaction?
The only one that had to was Los Alamos. The others looked at their processes, looked at their procedures, safety basis in place, and there weren't any changes needed. It was the Los Alamos that needed to change theirs.
So you guys have confirmed no other site needed to make any adjustment?
Yes, ma'am.
Okay. Thank you.
Thank you, Mr. Roberson. Mr. Rossetti, earlier you mentioned that after the WIP event, the department began to rely on enhanced chemical compatibility evaluations to understand the potential reactions in the waste drums. Could you summarize these evaluations and the staff's views on the challenges involving the execution of them?
Yes, sir. Before waste can be shipped to WIP, the department now requires an enhanced chemical compatibility evaluation. This type of evaluation is important because it helps the department identify hazards, which would then allow the department to devise strategies to prevent undesired chemical reactions. I would like to enter Exhibit 8 into the record. The department's enhanced chemical compatibility evaluation is based on a method published by the Environmental Protection Agency in 1980, as described in Exhibit 8. The EPA document describes a method for determining whether the waste could be involved in undesired chemical reactions.
Take a breath and so we can read this here.
Okay, sir.
Okay, go ahead.
So the authors of the EPA document performed a survey of accidents involving undesired chemical reactions in hazardous waste. They found that one of the primary causes of these accidents was insufficient or inaccurate information about the waste contents. Accordingly, the EPA method starts with collecting as much information as possible about the waste and listing which chemicals are included. The EPA document then provides a methodology to determine if combinations of any two chemical types could lead to undesired consequences such as a fire, explosion, or the generation of flammable gases. The purpose of the department's evaluation is to provide some confidence that inappropriate waste is not sent to WIP. The evaluation requirement is not designed to ensure safety at the generator sites where the waste is generated, processed, and/or temporarily stored. The board staff has identified challenges with performing chemical compatibility evaluations in waste. Some of these are listed on the second slide of Exhibit 8. One challenge with performing chemical compatibility evaluations is the uncertainty regarding the chemical composition of legacy wastes, which we heard either Mr. Schrader, I believe it was Mr. Schrader, talk about in the first session. Consider the waste buried at Idaho. Some of these wastes were buried in the 1950s and 1960s, and the documentation about them is not complete or does not exist. The wastes are also from a wide variety of sources and generating processes. While the department and its contractors have worked very hard to collect as much historical information and records as they can, gaps still remain. As an example, the department's contractor found that a chemical, beryllium carbide, could have played a role in the 2018 Idaho drum event. Before the event, beryllium carbide did not appear on the department's list of chemicals that could be in the Idaho waste. Another challenge is determining whether to analyze so-called trace chemicals. The WIP, Waste Acceptance Criteria, or WIPWAC, allows for trace chemicals to be excluded from the chemical compatibility evaluation with documented justification. However, if any chemicals are inappropriately excluded, important chemical interactions could go unidentified. Finally, chemical compatibility evaluations are not an end in themselves. If the evaluation identifies potential hazards, it requires the department to take further actions to address those hazards by implementing controls and/or treating the waste.
Thank you, Mr. Rossetti. Ms. Roberson.
Thank you, Mr. Chairman. So, Mr. Chung, Mr. Rossetti just highlighted the uncertainty associated with the composition of legacy waste. Can you describe how the department accounts for limited knowledge when analyzing hazards associated with this waste?
Sure. Dealing with uncertainties with respect to how we perform hazards or accident analysis is not unique to solid waste mission element. We have wrestled with this issue for a long time, even with tank waste in terms of chemicals and whatnot. So at the onset of the formation of our safety basis methodology, which goes back to early 90s, we recognize that we have to develop a set of what I would consider deterministically driven accident types as the starting point. In other words, we would so designate certain types of accidents to be analyzed, realizing that we are dealing with certain degree of uncertainties in terms of being able to correctly and accurately identify hazards, because you will only know as much as you would know based on the knowledge. So with that methodology, we also felt that it is still important to do a bottoms-up type of hazard analysis. So you do walkdowns, you look at the historical data, you interview. So you try to gather as much information as possible in terms of being able to perform that hazard identification accurately. And then you start to roll up in terms of, so of all these hazards, how can we group them or categorize them into a certain set of potential hazard events or accident scenarios so that we can come up with a reasonable set of controls, both preventive, mitigative, including defense in depth, including safety management programs, to be able to come up with that set of controls that we can rely on for provision of adequate protection. So in terms of the solid waste or true waste, we have come up with what we thought was very reasonably bounding material risk formulation 10, 12 years ago in terms of providing that additional margin of safety right up front in terms of estimating that material risk. We have historically proven that the things like release fractions and rest bubble fraction values contained in DOE Handbook 3010 were conservative. We also have demonstrated over the years that not only the 5-factor formulation, which also includes damage ratios, but dispersion modeling, whether it's for public boundary type of air dispersion calculation or enclosed for co-located worker, we have chosen very conservative set of dispersion parameters. So when you look at the totality of our accident analysis from a consequence determination standpoint, that we felt that our methodology is very conservative, right? So the uncertainty aspect in terms of the waste characterization, we have assumed that our overall accident analysis methodology would be still conservative enough to be able to develop adequate set of controls.
Okay. So let me, and if you're not the right person to answer this, I'm happy for anybody on. So some of the things we're paying attention to, for instance, I'm not implying that it caused the event at Idaho, but the commingling of waste would be one of those phenomena. Things that are done in the process of handling the waste, additive at Los Alamos. At the end of the day, because I agree with you and I love modeling, but at the end of the day, it's the waste. So something that Mr. Schrader said earlier when I asked him, how does WIP handle accepting questionable or difficult waste? And he said at the end of the day, there's sampling and analysis, which the department used to do a lot, but stopped doing because of the cost benefit. What's the tripwire for just freaking analyzing the waste?
As Mr. Schrader pointed out, that sampling could be done as a last resort, but if we make that as a standard method for so-called every unknown waste streams, that even sampling activities themselves bring about certain level of risk for our workers. So I think we have to carefully examine when we really need to do a sampling. At the same time, as part of our revision effort or any other mechanisms that we have in the department to make necessary correction from a safety analysis standpoint, I think we have to make that judgment very carefully.
And I guess, and maybe there is no answer, I'm struggling with, like an example of when that judgment would be
So the other thing that I mentioned about the likelihoodness of some of these events. Certainly what we have experienced at WIP wasn't something that we had anticipated. Right? So if you were to have nitrate salt with organics and commingled, incompatible, reactive chemicals, you need to use higher release fraction.
Okay.
We do believe, however, that because of the OE that was issued, that this complex responded appropriately in terms of, hey, we have looked at our waste streams, we looked at our treatment and the processing processes as known at the time, that we do not warrant to use that higher release fraction. That was a decision based on their evaluation. Now, when we go through the revision process for 5506, we will look at whether or not we need to adjust not only the release fractions, but do we need to make that it's going to be another judgment call in terms of, hey, do we think that should be analyzed as a likely event versus unlikely? Or should we look at that as anticipated versus likely? Because that will also reinforce in terms of the potential need to develop any additional controls at a safety significant level through that safety analysis process. So those are the kind of things I think we're going to go through in order to continue to bound at the same time at the same time that we can make a certain progress, because we still believe that WIP is the safest place where we can finally dispose our waste. So I think that's going to be a discipline and process where we look at all the options again in terms of not only the particular parameter within the 5-factor source term formulation, but also in terms of the overall methodology, and keeping in mind that we are dealing with certain level of uncertainties no matter what. So,
If I could, I'd like
Please.
to maybe share some insight into where we are in Idaho with regard to this question, because certainly sampling is possible, but sampling has its own set of hazards. Now, what we've got historically is most of the waste has reasonably good paperwork, acceptable knowledge, process knowledge associated with it. And right now, we're down to really the very tail end of the Idaho mission as far as true waste goes, as Mr. Rossetti's slides in the opening indicate. And what we're dealing with now is really a lot of the cats and dogs and some of the other stuff that the previous contractors have set aside, either because it was difficult or primarily because in some cases there's a lack of that proper documentation from the generator site, which for our waste was primarily came from Rocky Flats, but there were also other generators. So right now the contractor, and this is partly in response to the ARP5 event, that occurred, they are doing computer modeling on the basically interactions from all the chemicals that are in the waste streams that we have information about, and coming up with a set of controls that we can apply to that situation. But what we have, and this is exactly what to a sense what was in ARP5, is there's probably about 150 cubic meters remaining that we don't have adequate acceptable knowledge and documentation associated with. And so we are evaluating whether for the unknowns that sampling may be the appropriate piece, but the computer modeling has shown that the controls that we've developed after ARP5 are adequate for all the chemicals that we know that are within the existing waste streams. The other very important control that's in place is the waste streams are essentially segregated, and we've directed the contractor, and their analysis accounts for this as well as their procedures, but we don't commingle waste streams. So in general, it's when there is mixing, it's usually waste stream to waste stream. In the ARP5 event, as it turns out, commingling probably was not a potential issue, but it'll come out later that, and through the investigation, that it was essentially a collection of unknown waste streams. So there was the potential for commingling inadvertently, which wasn't really apparent at the time. However, in this case, that ARP5 drum was, and because of the lack of data, this was really some part of the characterization process that it was undergoing, as well as the initial treatment for removal of any prohibited items in accordance with the WIP-WAC. And the chemicals that actually reacted and led to the overpressurization had coexisted within that drum pushing 60 years at this point. That drum, I think, got on site in the early 1960s. And so it was actually this activity of initial characterization and treatment that ended up basically exposing the uranium to air that subsequently led to the methane generation from the beryllium carbide.
Thank you.
I guess if I could, I would conclude just to make sure it's clear. I believe that the sampling is currently under evaluation, but it is really for those waste streams and individual drums that there's not sufficient characterization already existent, because the majority of the paperwork that can trace a drum back to the generator has been fairly accurate.
Okay. Thank you.
Board Member Connery.
Okay, before I have a line of questioning on Idaho for Mr. Zimmerman, but before I do that, I have two quick questions for Mr. Chung with hopefully quick answers. One, based on what you said, my understanding is the department considers that release fraction of 0.205 only in the circumstances of improperly remediated nitrate salt. Is that correct?
And any other very energetic chemical runaway reaction that could be formed with other types of chemicals and organics.
So it shouldn't only be at sites which had potential nitrate salts. It should be at any site which could have that kind of energetic reaction. Okay, that's different than what I understood you to say earlier. And then my second question is the decisions to determine whether or not to use that release fraction, those were made at the site level because you put the OE out and it was up to the site to determine whether or not they were going to use that release fraction or a different release fraction?
It's my understanding the site responded and then headquarters have also reviewed the responses.
Okay. And in any case, did the headquarters overturn a site's determination?
I would not know that. Maybe Ted can shed some light.
No, and, in post-WIP event, and, all DOE sites, including NNSA sites, evaluated their waste streams per the OE that was put out.
Okay.
OE notice, that was in June, I think, of 2015.
Yes.
And all the sites applied DWEAK OE to DWEAK evaluation criteria, and they concluded that they did not have any such waste streams or very limited quantities. The only one from our side was Los Alamos, and that they needed to continue to evaluate for energetic chemical reaction. So headquarters agreed with it, and as with the site field office.
Okay, I appreciate that. I just wanted to clarify
No,
because I was getting lost in the long answer, so I just wanted a quick answer to that. But I want to turn to Mr. Zimmerman now. So, because we were talking about the WIP event, and based on your last bit of testimony, obviously we're switching over to talk about the Idaho incident in 2018 and the overpressurization event and subsequent radiological release. So, I want to focus on that for a few minutes, and I'd like to enter exhibit number 9 into the record. So, this exhibit shows the progression and causes in simplistic form. Of the April 2018 events as described by your contractor. We're still evaluating, but this is what the contractor postulates as the progression. So I just want to put that up there so everybody can see it. And because I like the pictorial description of it. So I'm not trying to beat a dead horse here, but Idaho has had previous experience with uranium fires as well as methane generating waste. Were these hazards considered in this facility safety basis? And if so, why didn't the facility have controls in place to prevent or mitigate the accident?
I guess perhaps a comment for the record on the drawing, but the uranium and the beryllium carbide were in the same drum. They didn't come from separate drums and then placed in the tray.
Okay, I think that's your contractor's drawing, but we'll make a note of it.
Okay.
Same batch.
But,
anyway.
I mean, the bottom line is the previous assumptions that we had in place was that any reaction would occur quickly and violently, for example, consistent with the pyrophoric reactions that had been observed previously throughout the history at Idaho. And we had not seen this type of event, which was basically a slow reaction and heating that led to secondary reactions. In this case, it was the beryllium carbide and essentially moisture from the air reacting to generate methane once the temperature exceeded 200 Celsius in the drum that overwhelmed the vent that was in place so that ultimately the lid came off the drum and released some of the contents into the room inside the ARP facility. Additionally, the control strategy that was in place at the time of the ARP event was not successful, again, because we were not aware of that rapid hydrolysis, so the beryllium carbide would generate large quantities of the methane gas. In fact, we were not aware of the beryllium carbide content within the waste drum, because although this drum was lacking a lot of characterization data, what data was available at the time was that there was less than 1% beryllium in the drum. Sampling post-event identified 30% beryllium. So that really was challenging even the ability for the contractor or DOE to have identified the potential for this event. Also throughout the process, there was basically some non-conservative decisions and a lack of questioning attitude that was conducted. For example, the folks that are really responsible for the facility it probably didn't look broadly enough at the 2017 event that occurred in the Advanced Mixed Waste Treatment Facility because that was a pyrophoric reaction that occurred when they opened up a sealed container inside of the box line. And in this case, it had become kind of an ingrained cultural issue that uranium in sludge was not reactive. And in this case, from the radiography, all indications were this was a homogeneous solid sludge that contained some uranium. Then in addition to that, as identified in the investigation report, the workers that were conducting this, when they opened up the drum and saw the materials, did notice that it was somewhat different than they'd seen in previous sludges. In this case, it was, they saw a silvery type powder substance, which was most likely the uranium in the drum, and it wasn't exactly like other sludges, and so that at that point, that issue again was failed to be raised at that point. So there were multiple barriers that were in place or expected to be in place that were not effective for this event.
So in general, what you're saying is you were relying on the operators to recognize that this was a waste stream that was poorly characterized and notice any differences in the waste stream as they were processing it, rather than any other kind of physical controls within the facility or monitoring.
That is not the primary control that we were relying on. It is one of the administrative controls that is relied on, and it is part of. And it wasn't necessarily the operators, maybe I misspoke. We're also doing, visual observation with trained and qualified individuals who can identify visually the specific waste stream back to processes, primarily at Rocky Flats. And so we're relying on that aspect also to identify, unexpected type conditions and just to have a questioning attitude. But the location where, this waste at the time was being processed does have engineered controls in place. But those are the barriers that I mentioned that failed, that allowed the drum to then, be filled and essentially put the lid on, which basically containerized the event. And again, that control set was really focused previously on the reactions are going to occur quickly, and they occur in the place where the engineered controls exist.
Okay, thank you.
So, Mr. Zimmerman, following on to Ms. Conner's question, so we understand that Idaho has implemented a thermal monitoring control after the event. Can you describe this control?
Yes. Yep. Since the event, we've implemented additional TSR level controls through, the evaluation of the safety of the situation that was conducted, as well as a significant amount of analysis that the contractors conducted dealing with basically all the possible adverse chemical reactions that could occur. So based on that modeling, it has concluded that for the known chemicals that we could put into the facilities, that those reactions would all occur within 16 hours based on the technical analysis and result in temperature rises that within that time frame should be within 3.6 degrees or less. So the control is basically we empty the drum into the tray inside of the facility where the engineered controls exist, and we essentially use a mechanical raking action to disturb the material, mix it with oxygen, and try to force any reactions that are, could potentially occur in that location where it is protected. And then hold that material in the area with the protective measures in place for 24 hours and conduct the thermal monitoring throughout the process. And again, as I said, if basically the temperature in the tray is within 3.6 degrees of the ambient room temperature, then the modeling shows that no further adverse reactions could occur once it's placed inside of the drum that could cause basically an overpressurization event like we had seen with the ARP-5 event. I do want to just
Okay.
make sure it's clear. It doesn't mean that there's no chemical reactions that are ongoing, just that the chemical reactions that may continue on and decline off would not have adverse consequences.
Thank you. I think that was going to be my next question. It's very important. So now my next question is, obviously DOE has a lot of information available to it, both from Rocky Flats, and at one time DOE had its own standard for stabilizing uranium to create the oxide. Was that body of knowledge relied on for validating this control? Do you know?
I mean, I don't know that that body of knowledge was used for this particular control. I know the technical basis for how this control was developed for our application and the waste that we have. But also, as I understand it, this control is a form of actually, like I said, reacting the waste, treating the waste to be less reactive.
So in the worst case, it would be less reactive. Is there any monitoring after the waste is packaged and set aside for whatever's next, disposal? Is there any temperature monitoring, any thermal monitoring, or any other?
There are some additional controls. So after it is basically packaged, shouldn't say it's packaged. So this occurs in a place where the personnel don't have access. Once it meets the first check mark where it's less than the 3.6 degrees from ambient, it's been held for 24 hours, it comes into a drum packaging station. And in that drum packaging station, there are additional thermal monitoring that's in place, which is immediately prior to placing the material inside the drum. And after that point, it would be placed in a drum, and there are some additional monitoring after it's placed in storage, just in the general area for potential flammable gases and things like that.
So after it's placed in storage, there's monitoring for flame gases. Is there? Go ahead. No, I don't want to interrupt you.
I was going to say that's in the general area, yes.
So it's monitoring the general area.
Right. The contractor is considering whether there's any value to conducting flame gas sampling on every drum after it's treated. However, when we evaluate it, we got to look at what is the value of that kind of sampling and what would we do with that data. And right now, the analysis looks like the control set would be exactly the same as what we have, except if we did the flame gas data and it tested high, we would put the drum into basically a single planar array, mark it with a non-conformance report so that it's just an added layer of control to ensure that it doesn't get shipped to WIP in any inadvertent manner. And then ultimately, flame gas sampling is required prior to shipping to WIP.
How long does stuff stay in storage once it's packaged?
Well, for us, we're projecting at the current shipping rates that we have to WIP, it'll take us till about 2028 to complete shipping all of the true waste from Idaho to WIP. So this stuff could be in storage for a decade.
Thank you.
So far, we've talked about chemical compatibility evaluation in waste drums. One specific adverse chemical reaction is the generation of flammable gases, which you were just discussing, which can cause overpressurization or deflagration events. We issued a board letter on March 12th entitled Idaho Waste Drums with Elevated Methane Concentrations. I'm going to ask Mr. Rossetti to highlight the concerns that we had with the flammable gas generation and mitigation.
Yes, sir. I would like to enter Exhibit 10 into the record. Solid radiological waste can generate flammable gases and vapors through radiolysis, chemical reactions, microbial activity, and evaporation. If there is a flammable mixture of gases and an ignition source, the gases can burn in what could be a deflagration event. If a deflagration occurs in a drum, the pressure in the drum would quickly increase and the drum could rupture and release radiological materials. The contractor formal cause analysis does not indicate that a deflagration occurred in the April 2018 event at Idaho. The board staff is still evaluating elements of this analysis. The department often puts solid waste into drums with vents. That is, each drum has a vent. The purpose of the vent on the drum is to allow any gases to escape from the drum. The safety basis for the facility where the Idaho event occurred states that a vented drum should not reach flammable conditions. However, the board staff has learned that the department's contractors at Idaho have detected potentially flammable conditions in several drums. This observation demonstrates that simply having a vent will not necessarily prevent a drum from reaching a flammable condition. If gas is generated more quickly than it can leave through the vent, gas will accumulate in the drum, and the drum could reach flammable conditions and or over-pressurize. If a drum is known to reach flammable conditions, extra precautions could be enacted to help prevent ignition. While the department does measure the concentrations of flammable gases in drums before shipping those drums to WIP, the department does this to ensure safe transportation to WIP as well as the safety of WIP. There is no requirement for taking this flammability measurement to assess the safety of the drums while those drums are at Idaho. As a result, the department has not taken such a flammability measurement for thousands of drums that are currently at Idaho. Thus, the department does not know whether any of these drums are currently flammable or nearly flammable. After packaging legacy waste into new drums at Idaho, the department often stores the drums in buildings that lack confinement ventilation systems. If a drum rupture were to occur in those buildings, the exhaust from those buildings is not actively filtered to reduce the release of radiological materials to the outside. Having a confinement ventilation system would mitigate the impacts of such an event to people outside the building.
Thank you, Mr. Rossetti. Ms. Connery has some follow-on questions on this topic.
And I think some of these you've addressed already, so I'm going to, again, try to go through them quickly, but they're in the order in which I wanted to ask them to lead to something. So in your May 7th response to the department, from the department to the board when we sent you a list of questions, you noted that over 10,000 drums at the site have not yet been tested for flammable conditions. And you said that untested drums would be sampled prior to shipment to WIP because that's a requirement for WIP. But as you noted, they could be sitting there until 2028. And so my question was going to be, is it feasible for these drums to be tested at an earlier date? And it sounds like you're investigating what the benefit of that would be. And at this point, jury's still out.
That's correct.
Okay. Are there any additional controls that you apply once you know that a drum is flammable? You said that you isolated those drums and put a note on them so that they're not inadvertently moved, but that doesn't necessarily prevent anything from igniting them.
Well, I mean, first, the safety basis does not identify TSR level controls that would be required for those drums. The controls that we do have in place are defense in depth, as well as those that are based on basically industry standards or regulatory requirements. So there are a suite of controls in place. Predominantly, the controls are driven by RCRA and OSHA. So all the drums are handled and stored in accordance with 1910-120, Part J. Mm-hmm. And that's consistent, with all the industry standards and how that type of drums would be handled, or all drums. So some of those controls, we use a trained and qualified workforce. We have HEPA filtered air vents. We also have, waste container integrity inspection programs, as well as spill containment programs have been established. And we are evaluating, other potential controls that we might be appropriate to put in place. And we have had an independent review from Jensen & Hughes take a look at the controls. They agreed with the controls that we have in place as being adequate. They did make some recommendations for additional controls, which we are evaluating. But some of the controls they recommended, for example, a blast shield, for the forklift operator on the cab of the forklift, or that the spotters maintain a distance greater than 10 feet away. I met with a group of waste handlers when we got that report and talked to them about it, as well as the contractor. And in general, the workers have some concerns with those additional controls being added because they actually make their job performance less safe. The the blast shield would make the visibility, less visibility. And it's basically a job where, placement of the drum has to be within inches. And they are aware of the hazards, and they're comfortable with the existing controls that are in place. So it's one of those, it's like I said, we got to be careful. It's easy to add controls to address one hazard, but we have to make sure we balance out the total impact so that we can allow the workers a chance to do their job in a safe manner.
Right. Yeah, obviously, human factors plays into it. Can you said are there HEPA filters in place in every place that you store drums at Idaho?
No, I was talking about their vents on the drum are HEPA filtered.
Oh, okay. You're talking about the
Right,
drum
yeah,
vents.
not all the facilities.
Oh, okay. So the facilities may or may not have them.
For the most part, they do not have HEPA filtered exhaust in the storage areas.
So, Mr. Griffith, in the response to us, again on May 7th, you said that the department is directing EM to asking the generator sites to complete an extensive condition in fiscal 19 to determine the population of product drums at those facilities that have not had their flamm gas concentrations measured. Is this part of the information that you expect to get in September? Is that when we should expect to see that information?
No, I think it's all part of the overall safety alert you're talking about there.
Yeah.
Right. It's going to be part of that. And that was issued.
And
At
Mr.
the end
Wyka,
of
can you
May.
discuss any plans NNSA generator sites have to determine the population of drums which have not had their flamm gas concentration?
Yes, ma'am, and as previously mentioned, we sent out a similar type alert, went out to all the NNSA sites, pretty much the same type of actions for them to look at.
An email? You sent an email?
Yes.
Okay.
Email alert. And I did that because I knew the department alert was coming out, so I wanted to get that out rather than waiting for the alert. And the plan is to meet with all the generator sites at the True Waste Program Review in October 2019 and review the information.
Thank you.
Thank you, Ms. Connery. Mr. Zimmerman and Mr. Wyka, I think you've addressed this in pieces and parts already, but I wanted to ask it very clearly. If you look back at the April 2018 event, what are the lessons learned that have been or should be communicated to the other generator sites, including lessons learned from the initial response to the event?
I think that a few of the things, especially on the initial response, in the case in Idaho, there had been a significant number of false alarms with the fire department. And although they're required to basically respond in the turnout gear and the respirators, they didn't make their first initial entry in respirators. They opened the door, found smoke. They weren't expecting the condition they'd been sort of conditioned to expect there, unfortunately. So we've basically on the site, we are improving that communication between the project and the fire department. We're making sure that they are aware of the potential hazards in every facility, and we're also looking at whether or not we have the ability to provide some sort of remote identification of the potential hazard as they respond. So I mean, those are really focused as far as the response type lessons learned or actions that we are taking. And as far as the event, I think I kind of touched on it. For us, it's that basically any form of uranium should be assumed to be reactive until you've proven otherwise. I think that's probably the big takeaway for us. One that we've been conditioned, unfortunately, for the last 15 years, been conditioned in another way, that basically it's the roaster oxides that are the potentially pyrophoric or reactive material.
Well, I'm sorry to interrupt you, but my question really is, how have you taken those lessons to other sites?
For us, we issued the ORPS report as we're required to do. So we issued the ORPS report, and that was the primary mode that we've done it. We have also provided presentations and briefings in various public settings such as Waste Management Symposium that provided an overview of the event as well as the lessons learned and some of the actions that we were taking, as well as providing input to headquarters with regard to the development of the operating experience announcement. We also, I personally shared this information through the biweekly call that the field managers have and alerted folks. And I think that, and my safety staff did the same thing through their typical communications.
Okay, thank you. Mr. Wyka, did you want to add anything to that?
Yes, sir. Just a couple of things. First, we provided the alert, which sort of summarized the event to all of our NNSA sites, as well as the contractor's report on the dynamic specifics of the event. And we linked that a little bit. We linked that with the WIP event as well, especially, and we focused on the two root causes, I'd call them contributing causes within the alert, which is, management failed to understand, characterize, establish, and implement adequate processes, controls for treating waste that lack documented origin and process information, as well as management failed to continue to develop the safety culture over a number of years. And, those are two significant contributing causes, which are probably, those would be similar to most events that we have. So I really want them to pause, think, and refocus, on these
Okay.
contributing causes.
Thank you, Ms. Roberson.
Thank you, Mr. Chairman. I think this question is to you, Mr. Chung. A few minutes ago, somebody on the panel raised the topic of defense in depth. So if you would please discuss the concept of defense in depth and how it's been implemented in environmental management generator sites.
Defense in depth philosophy and its application and how it's implemented throughout the EM complex have been fairly well articulated in various DOE directives and standards and whatnot. In particular, we need to not rely on a single control for adequate protection. We have to have multiple layers, and we have been trying to institutionalize the hierarchy of control selection, prevention first, then mitigation. In terms of the safety classification of controls, we, of course, have a safety class level controls for public protection. For co-located and significant worker safety, we have safety significant. We also have administrative controls that provides some aspect of defense in depth. Although it was not called out as a safety basis driven controls that Mr. Zimmerman talked about post R5 event, those two operational restrictions that are written much like Pacific admin controls that are now referenced in technical safety requirements are, in fact, a form of defense in depth measures that we have decided to add. So it's a basically, have multiple layers of controls so that we have a reliable set that provides adequate protection.
Thank you. Mr. Rossetti, can you summarize the DNFSB staff's understanding of how the concept of defense in depth is being implemented at DOE waste generator sites?
Yes, ma'am. I would like to enter Exhibit 11 into the record. DOE Standard 3009 defines defense in depth as a fundamental approach to hazard control for nuclear facilities that is based on several layers of protection to prevent the release of radioactive or other hazardous material to the environment. Having multiple layers of protection is especially important with the hazards we are discussing today. The WIP and Idaho events show that the department's efforts and controls to prevent such events may not always be successful. I will use the second slide of Exhibit 11 as an example to demonstrate how the department uses defense in depth to protect the public. The picture on the left shows drums of waste inside a facility, and the picture on the right shows waste that has been packaged and stored outside a facility. On the left, the waste inside of a facility normally has several layers of controls for release events. These layers of controls can include a confinement ventilation system that filters air before it leaves the building, as well as equipment to monitor the air for a release. The example also includes fire protection controls, such as fire detection and suppression controls. These controls illustrate the concept of defense in depth because there are several layers of protection to prevent or mitigate the release of radioactive material. Contrast this with the picture on the right. The only control to prevent or mitigate a release of radioactive material for the waste stored outside of the facility is the waste container itself, including the passive vent. Several sites store waste drums and containers outside. Therefore, they rely on the drum and passive vent as the only engineered controls to prevent or mitigate a release due to reactions inside the drum. Given the uncertainty in the waste contents that we have already established in this session, the board staff believes that this represents an opportunity for additional layers of controls. I would like to enter Exhibit 12 into the record. This exhibit uses several facilities at Los Alamos National Laboratory as examples to show how controls are implemented inconsistently with respect to potential chemical reaction events within waste. As I said before, confinement ventilation systems limit the amount of radiological contamination released from a facility, but several storage locations do not have this control. Exhibit 12 also shows that many of the facilities do not have continuous air monitoring and only have relatively infrequent monitoring for contamination on surfaces. Therefore, in the case of a potential chemical reaction event, there would be no real-time notification of the event to enable a response unless a worker happened to be in the area to see the event. The board staff again believes that this represents an opportunity for additional layers of controls. The Idaho event illustrates the importance of having defense in depth. After drums are packaged, the contractor at Idaho often moves them to locations that do not have confinement ventilation. However, in the case of the April 2018 event, the drums happened to still be in a location with confinement ventilation. This system helped avoid any releases outside the building.
Thank you. We should just leave this exhibit up.
Thank you, Ms. Roberson. Ms. Connery.
I know this looks like a setup, but it wasn't intended to be a setup. We're actually trying to make a point here. So my question is for Mr. Griffin. Obviously, Mr. Rossetti just highlighted the lack of defense in depth for waste drums in certain situations, especially when stored outside. Given the experience at WIP in Idaho, it's prudent to assume that drum ruptures can and do occur, and those are just two of the most recent examples. There have been many over the years. Can you just let us know what your expectations are for having multiple layers of controls at EM facilities and how you've communicated this expectation, or whether or not you're going to take some of this information into consideration as you're getting the information back from the safety alert going forward?
Well, of course, let me address the last point. We'll obviously take that kind of information into consideration as we go forward. I mean, we clearly want to do that. We're trying to be a learning organization that understands, strives to understand where we can improve and makes those improvements. Regarding the earlier exhibit, I guess, whatever the pictures there and all that, I understand the point of the pictures is perhaps a little bit out of, there's not any real context there. I mean, it's outdoors and indoors, and it pointed out the potential lack of information, but again, I don't know the particulars there and what information did we have, or do we really know about the outdoor drums versus the indoor drums? I'm not trying to get legalistic on it, but it's a little bit hard to comment on something that's just a picture. Clearly there's a point to be made there, and I understand, the potential points there, but I think we also have to consider that we're not dealing with quite that sort of, we're not dealing with pictures, we're dealing with real drums with where we either have an understanding or we don't, and we try to work with those particular circumstances. So But going forward, yes, we clearly, that's the point of the safety alert, and the information we'll be gathering from that is to look at these situations. And then, as you note, if you've read through the safety alert, you'll note at the very end we are going to fold this into, we're asking the sites to use 5506 to address it in their safety analysis, and we'll be folding that into any improvements that we make in that as well over the next year.
Yeah. And I take your point about the picture. Those that was supposed to be representative. It's not a decisive picture of two.
Yeah, I understand.
The drums are not necessarily they don't necessarily have the same content. They're not necessarily the same site. So it's representative versus definitive. So,
right. Thank you.
So, Mr. Wyka, again, same question to you with regards to NNSA. I'm assuming you're going to have a similar answer, but we want to make sure we address this to both.
It would be a similar answer. It's something that we need to continue to learn, especially from this alert in the waste management area. And I think
Could use your mic on.
Thank you.
As a learning organization, it's something we're going to have to learn as well, and probably learn collaboratively with our EM partners. And for us, I think this slide is accurate. One of my biggest concerns is the storage of drums at the hang pad. And I know there's concerted effort to get them from the outside and get them into the Transatlantic Waste Facility, which is a safety significant facility built very robustly, in a much safer place than outside.
Thank you, Ms. Connery. Board Member Roberson.
Thank you, Mr. Chairman. So, Mr. Wyka, we spent a lot of time talking about legacy waste here. And even though EM will be generating waste in the foreseeable future too, let's focus a little bit on what NNSA is doing to make sure that in 2 decades we wouldn't be having this conversation about waste you're generating now. So what is NNSA's strategy for ensuring safety throughout the life cycle of newly generated waste?
I think a lot about what we talked about today, is to make sure the processes, procedures are in place, using the enhanced AK to make sure that the waste through the interface waste and the document list, the BOK basis of knowledge, the chemical compatibility to upfront and packaging the waste to make sure we have a complete set of documents for the waste being generated. It's also processes and procedures. One lessons learned from the WIP event is as we change things, to make sure that those changes, no matter how small they are evaluated, because collectively, changes can make a significant impact, in the waste and stuff. So it's doing that. It's also making sure that we have the right qualifications, and that's included in our technical qualification program on a federal side, and that it's a key piece of our oversight strategy as well. Getting back to my initial point that the success that we have in the waste management directly impacts our mission at hand. Not only the current mission but our future mission.
So, and I appreciate that. I mean, we look at everything you guys produce, and one of the things we noted in the I don't want to use the acronym, generator site technical reviews is that I would say is a vulnerability is insufficient specificity in procurement controls for chemical absorbents that may come in contact with the waste. And they noted this as a concern for Livermore, Los Alamos, Savannah River, Oak Ridge, and Idaho. And to me, that I don't know what NNSA has done with that, but maybe you can tell me.
Oh, that's a good point. I can't actually expand on that,
Okay.
but I know and that's something I'll obviously take back with me.
Okay.
Because,
Okay.
as I mentioned previously, I do value those GSTRs
Right.
because they look broad programmatically, and some of the same principles apply across the board, not just waste management.
So maybe you can take that for the
Yes,
record.
ma'am.
Thank you, sir. And I think my last question, Mr. Chung, is to you. So the department has previously employed stabilization methods to treat certain waste at Los Alamos to make it less reactive by adding inert materials. What's the department's perspective on more widespread use of such methods to make waste less hazardous? And I'm not suggesting there's one size fits all, but is this a strategy in the toolbox that the department still considers?
Jack may have some
Okay.
clarification or some added feedback on this question, but I think that applies more to the newly generated waste in terms of making the waste as that gets generated less hazardous, less challenging, as opposed to dealing with the legacy waste.
So what is the waste from D&D called?
Excuse me?
What would waste from D&D be called with that? Is that in the category of newly generated? I'm asking, I really don't know.
Well, the D&D activities that are ongoing, that we have a much better record in terms of what is in the building.
Right.
And plus the fact that we go through a very careful process of deactivating the materials before we go through the demolition activities, which become the bulk of the waste. So in terms of treating any kind of reactive materials, like we used to for surplus plutonium coming out of Rocky Flats, Hanford, Los Alamos, we did decide to thermally treat to remove certain prohibited items or moistures and whatnot, so that they become much more stabilized for long-term storage as well as future utilization. I'm not sure that that level of pre-treatment would be required for the typical waste that would be generated from our typical D&D activities.
And
but if we
ahead,
run into those, like it's not a radioactive material, but like a mercury issue at Oak Ridge, we are designing, and we plan to construct a mercury treatment plant so we can dispose that particular hazardous material in a safe and environmentally compliant manner. But in general, I haven't really thought about coming up with any pre-treatment like stabilization to make the waste management and disposal less hazardous.
No, and I understand, and as I said at the beginning, I'm not assuming there is some across the board. Really what we're focusing on are the waste anomalies that come up. And the question was, has the department negated that as a tool in the toolbox when it comes to challenging waste?
But we take it as a case by case,
right,
in terms of whether or not we need to go through that extra measure in terms of pre-treating or thermalizing or stabilizing.
Okay, thank you.
Thank you, Ms. Roberson. Do any of our fellow board members have any remaining questions for the panel? Okay, hearing none, I want to thank all of you for being here today, Mr. Zimmerman, Mr. Griffin, Mr. Chung, and Mr. Wyka, and also Mr. Schrader, who's still in the audience. Thank you for all taking time to be here, and I know you didn't just walk in, you had to do some prep work, so we appreciate that. My acting general counsel says that we have nobody who has signed up to make a statement in session 3. Did anybody think he or she signed up and didn't? Okay, in that case, we are going to dispense with session 3, and I'm going to ask my board members for closing remarks. Ms. Roberson.
Thank you, Mr. Chairman. First of all, I want to thank all of the participants in the panel. I certainly learned some information along the way, and I hope it was beneficial for the department, including NNSA. The board takes this mission area in the Defense Nuclear Complex very serious, as I know you do, and our questions were intended to both highlight and elevate some of the challenges that lie, not just today, but in the future as well, too. So I appreciate your participation, and thank you.
Ms. Connery.
I'd also like to echo the thanks for all you coming today and doing all the prep work. The thing that encouraged me the most is the repetition of the phrase learning organization. I mean, you're going to have to be a learning organization as your mission continues, both on the EM side and on the NNSA side. The reason that we were asking questions relating it back to WIP is because we believe that DOE as an organization has to be less reactive, no pun intended, and more forward-thinking with regards to hazards that could come up, and not simply putting out lessons learned about the last accident. We need to be able to predict the next one prior to it happening, and hopefully preventing it or mitigating it as it happens. So that was the nature of the question, and it wasn't meant to do anything but be thought-provoking, not provoking in any other way. So we also do this for the public because we think it's important for the public to hear how it is that you're protecting the public health and safety. And because of the nature of the event in Idaho, I don't know that it got a lot of attention given to it in the public sphere, and we've gotten a lot of questions about it. So this is, for us, very important, but also I think very important for the public to understand what actually took place, what the investigation looked like, and then what actions that you're taking to address those issues in the future. So thank you.
Thank you, Ms. Connery. And just one more thing for anyone who wants to submit a written comment for the record, we'll hold the board, the record of hearing open in order to get those for 30 days. So if you weren't able to be here, but you'd like to submit a written comment, please do so within the next 30 days. Our goal for this hearing was to discuss DOE actions to strengthen the safety posture of the nuclear waste operations, of solid nuclear waste operations, and gather information on the safety controls to address vulnerabilities associated with handling and processing solid nuclear waste at defense nuclear facilities. To that end, we heard testimony from several department officials representing both environmental management and the National Nuclear Security Administration, as well as, and we may get some comments from members of the public should they submit them. The board will consider the information gathered this afternoon to inform any actions that we may take regarding these issues. Once again, I thank everyone for your participation at this hearing. The record of this proceeding will remain open until July 20, 2019. This concludes the public hearing of the Defense Nuclear Facilities Safety Board. We are adjourned.